Hey, yes. Hi, everyone. As we begin our countdown to the panel discussion, hope you guys had a good lunch/networking session. Hi, Lena, can you hear me?
Yes, I can hear you.
Great. All right. Welcome back, everyone. So I think what I'll do first is introduce the host for the panel discussion. So we have here Lena Nyong'o, who is passionate in data analytics and machine learning. She's dedicated, highly motivated, organized, and goal-oriented. She's a biostatistician who is able to manage time, prioritize, and ensure confidentiality of information. She possesses good leadership skills and contributes towards achieving the highest level of efficacy. She has a Bachelor of Science in Biostatistics, a Master's in Applied Statistics. She's passionate in learning new ideas to expand her skills in data analytics. She prides herself in seeing that tasks assigned to her are completed on time and actively contributes to the overall success of the teams which she is a member of. Welcome, Lena.
Thank you. Thank you. Okay.
Sorry, I was also going to quickly introduce the panel participants, and then I can hand it over to you. Is that fine? Okay, great. All right, so for our panel, we have Dr. Chen. Quang Chen is a social entrepreneur and a computer scientist. He is the founder of Antara, a tech-enabled health service delivering patient-centered care via health navigation, automation, and data science. Prior to this, Quang was the founder, CEO of Captricity, sorry.
Thank you.
Where he developed the first AI that reads handwriting better than humans. He was the recipient of the MIT Technology Review 35 Innovators Under 35 Award in the humanitarian category for his graduate research focused on data-centric approaches to increase the efficiency of health clinics in Tanzania and Uganda. His work has yielded several patents and the Best Paper Awards. Quang also holds a PhD in computer science from UC Berkeley, BS in computer science, and a BA in comparative history of ideas from the University of Washington. Glad to have you on board.
Thank you.
And then we have Dr. Lawrence Deru, who is a lecturer and research fellow at the Department of Computing at Jomo Kenyatta University of Agriculture and Technology. He is also the Dean at Jenga School of Data Science and AI, and an adjunct at Pan-Africa Institute of Basic Sciences, Technology, and Innovation. Dr. Deru has a PhD in computer science, specializing in artificial intelligence and fuzzy logic from University of Paris, and a master's degree in software engineering from Jomo Kenyatta University of Agriculture and Technology. His current research interests are AI, ML, and data science. Welcome, Dr. Deru. And we also have back with us Leila Lee. We've already introduced her, but for those of you who are just joining us, let me go ahead and do so again. Leila Lee is the CEO and co-founder of City.AI, a software company that builds solutions to detect and mitigate AI bias and risks. Leila has lived and worked across 4 continents, including China, the US, Japan, the UK, the Netherlands, and Kenya, and has managed to scale data solutions and tech teams at Philips, Vodafone, and Tesla. She holds 2 bachelor degrees from Boston University and a master's in computer science from Harvard University. Welcome back, Leila.
Thank you.
And then we have Utu's very own Zakia Mustafa, who is an artificial intelligence engineer at Utu Technologies. She has experience building machine learning products in the financial sector. She did her diploma at Akira Chicks under the Code High program, where she launched a sanitary pad dispenser prototype. She is passionate about building artificial intelligence communities and is a program coordinator at Nairobi Women in Machine Learning and Data Science community. She is also a community champion supporting the Mozilla Fellows in building their Kiswahili dataset. Welcome, Zakia.
Thank you, Rahul.
All right, these are our panel hosts. Over to you, Lena.
So in this afternoon session, we have a panel of speakers that have been introduced who will speak on the skills requirement for applying artificial intelligence and machine learning workers. So several organizations who are training the junior applied artificial workers, including the gender that has been spoken before. But from our experience, there is shortness of the program and resulting lack of some of the computer science and maths fundamentals can be appropriate. So we want the panelists to explain to us, is it sufficient for an artificial intelligence or machine learning applying person to learn not much more than specific software frameworks and some basic about the employed versus obtaining a deeper understanding of the understanding maths and methods. Like how much of the theoretical a computer science, a good software engineer actually needs to know. When it comes to an artificial intelligence and machine learning in practice, particularly setting up a data pipeline and some model management, the subjects of these debates usually overlap at some class. So want this session to be more interactive, I'm going to call all of you before that I have the name. And for example, if I may just
Lena, is it just me or I think your voice is breaking a bit?
I think the connection or the microphone is not perfect.
Are you getting me? Are you getting me now?
That's better.
Yeah, it
better
is
now.
better.
It's better. Thank
Yes.
you. First of all, I would like to ask Kwang Chen, how much maths and particularly statistics background is required in practice for deciding whether a given data set is suitable for use in various machine learning methods? Kwang Chen, kindly.
Sure, I think that's a good question, and maybe that's a good place to start. You know, as someone who's had to take a lot of coursework in math, you know, I think we all laugh about sort of when was really the last time we had to use trigonometry in our daily lives. It's probably not a lot, and so I don't feel like, you know, the outcome of this conversation or anything I say should be taken as a gating function into the field. I would say that certainly machine learning is for the mathematically inclined and the statistically inclined. But I don't think that just because you haven't had the coursework, it can't be picked up, but it needs to be learned. And so, you know, in order to evaluate a data set, I think we sometimes think that we want to throw every feature into the mix and let the model sort it out. Without an understanding of, you know, where there might be features that start to, you know, collinearities, relationships that start to pollute and trigger overfitting, you know, it certainly helps greatly to have a statistical background where, I mean, you have to be able to understand the descriptive stats of your data set. You have to profile your data. You have to understand some basic skills. And so I guess that's really kind of a non-answer, a way for me to say it's really important. You got to learn it, but it shouldn't be a gating function.
Thank
Yeah, I guess for us, when we're looking to hire data scientists to join our team, when we're looking at people's backgrounds, you can kind of separate people into kind of so-called expert data scientists or citizen data scientists, if you will. So mostly when we're talking about the expert data scientist who has, been traditionally trained, probably has a bachelor in mathematics or studied computer science more systematically throughout their degree versus like say someone who's taken some Coursera courses and then trained themselves on Python. I think throughout the experience that I've had, it's quite a big difference in terms of people coming from two different backgrounds. And it's also like, Kwon has said, it's not that you cannot learn, but I think if you want to progress in your career and then to move deeper into different domains within machine learning, that's quite crucial. But if you you're just getting started as an entry level, data engineer, data scientist at a company, knowing what libraries to use and how to make things work in a way is good enough. But if you want to progress, I think it's quite important to actually have a very solid understanding of all the tech behind it and the process that's involved and the statistics and all the mathematics that probably wouldn't be used anywhere else besides for this particular job and the particular projects that you're working on, I guess. That's at least my take on it.
Thank you very much for that brilliant explanation. Mustafa, do you have something to say?
Yeah, definitely. So I'm here representing the other parts, the ones that didn't go through traditional background. So yeah, so I agree. Statistic is a very very necessary initial step towards learning machine learning and AI, especially descriptive. If you do descriptive statistical analysis, like understanding the central tendencies, understanding measure of variability and all that, and also there is data types in statistics. So if you don't get to understand the data that you are dealing with, then it becomes a problem later on. So yeah, it's really important to do statistical analysis in your data for a better outcome. So yeah.
Thank you very much. Dr. Andy, I can see you joined us. You're welcome.
Yes,
welcome. I may pose my question again. I was asking the other panelists, but how much maths and that's being statistics background is required for deciding on a suitable machine learning or other artificial intelligence method, whether, for example, whether a trained model fulfills its purpose to a satisfying degree. Is it sufficiently fair or bias-free? Things like that.
Thank you so much for the question. And I think I would want to agree to a good extent with the previous speakers in this panel. And thank you for the invite. The way I see it is that as it has been classified into two sections, there are those people who want it to go into the future. They plan to even be involved in the idea of even designing or even creating algorithms themselves. I mean, a person who sees as a person who can even contribute, not just a consumer of a certain technology, but a person who sees that they have the ability to go ahead and be involved in the issue of designing algorithms. So if you're going to be at that stage, then I think I would say that you will need deep mathematics. You will need to be able to tweak those models, and that understanding is needed. The mathematics is important. But if it comes to the other end where you just need to, maybe a user, run some level of a machine learning algorithm, perhaps you can survive with a basic understanding of what, or without the traditional mathematics, so to say. But there is also something else that I think I would add just a small bit around that, which is, in essence, what are some of, looking at even the mathematics, what is this mathematics are we talking about? So, because even then, there is the depth to which you will cover some sections. So as a self-trained person, perhaps probability and statistics, I would say even the basic, you cannot survive in data science without having some knowledge about some ideas around probability and statistics and how it works. But there is level. There is also the calculus that you may need when you're talking about tensors and all those kind of things. You will need some level of calculus and even deep learning and understanding of that. You may need some level of calculus. So I think the way I would put it is that even when it comes to that mathematics, it depends with some levels. Thank you.
Brilliant. Thank you for that. And for my next question, how much software engineering background is required for successfully setting up a working data pipelines at scale and also to manage model deployment effectively? Kindly function.
Sure. As a grad student, I never got good at software engineering. And the outcome is that you may have a model that works pretty well. That's it. If you can't deploy it to production, then it's not really doing anything. And so I would say that there's a different breed of software engineering skills that's necessary for especially the part where you deploy to production. That's something I'm going to cover in part in my talk in about 45 minutes here. But the type of runtimes that are necessary for hosting and running inference on a model is quite different than a common web application. We're talking about asynchronous runtimes where it's heavy on compute and memory. There's considerations about whether you want it to be competing with your database server or application server. And of course, monitor and evaluation is a whole thing. There's whole companies out there now that specialize in training and inference runtimes like weights and biases and ML flow. And so it's not only a necessary ingredient, but it's also kind of a separate job, okay? And so if you're part of a very small organization, you might learn enough to put a model up and have it run synchronously and produce a few results. But if you want to run it at scale, you might think of it as, there is your machine learning engineer, and then there's your machine learning DevOps person.
Yeah, I agree. That's sort of what we are observing now. Like before in the organizations that we worked, I guess the larger it is, the more focus everyone's role is. Like you have a whole data engineering department that's doing, all the ETLs and then all the data cleaning and the data prepping that you need. And then moving on to people that might specialize in building the algorithms, and then the ML engineers that actually take care of the deployment part. But if you're in a small organization like ours right now, we're a team of 7 people, and we kind of jokingly says everyone on our team, their title should just be the guy who does stuff, because some of them might work on some front-end stuff, and then some of them, also handles DevOps, and they are also working on our algorithm services. So I guess in that regard, you need a little bit of everything. But I think in this market, it's not very possible to say I'm an expert on everything throughout the machine learning process, that I can do end-to-end everything and build everything and deploy everything by myself in that regard. So like it's good to understand the whole process of how this is done, but I guess when it talks about when you talk about how much software engineering background is required for this, then for a data scientist, if you're just focused on building the model, then the software engineering skill in this is probably not as important if you really focused on like the ML engineering part of deploying a model. But I think the most important part in this is probably a lot of the code ethics and just generally, how do you maintain your code base in a clean and efficient way so everybody can work together? That's very important. Like we've had data scientists join our team who has degrees and who specializes in this, but never really developed any applications or worked with any other type of engineers before. And our software engineers on the team are actually really afraid to read his code because it's all spaghetti code, and then he doesn't really write a lot of comments. And I think that becomes a much larger problem for a team to work together. than if a person specifically lacks software engineering skills.
Thank you.
I think on that, just to add on to that as well, I would say maybe my statement is that I always tell my students that what I've experienced from the field of teaching at Jenga and even at the university is that the best data scientists are, to a good extent, software engineers. That's something that I've seen, and the reason why I say that is because the inner working of, as Rina has said, if you look at if you're going to have somebody working in the whole pipeline, they'll need to understand some bits and positions of the other people coming in. So even if you're just going to be one person within the whole pipeline, an understanding of the system thinking is needed. System thinking, I mean, seeing the way the whole data gathering it's coming in, the data warehouse is built, being able to see how it is distributed is so important that we have the whole picture in mind of the designer. So what I would say is that I would really say that at the end of it all, the higher the skill set that you have in terms of your entry behavior, the higher, the more competent you are in software and all that, I think the more you'll fit within the whole setting of data science. So maybe it's an area that has slots for even the one who has and they're just as small skills as possible in software engineering. But I think I would say eventually, if you want to succeed, software engineering is a component that I would find to be very crucial.
Thank you.
As for me, I've been moving around software engineering and data team a lot. So, and I totally understand, like, if someone is a data scientist and doesn't understand the software engineering part, which is also okay, and that's where, like, I can come in, like, especially when you're at a small team, you get to learn a lot and assist where someone is less skilled. So, yeah.
Thank you. One more thing, if you have any question, you can put it in the Q&A so that I can be able to see it, or you can just ask it. There is one question there. How possible is it to start your own company as a data scientist? Anyone? How possible is it to start your own company as a data scientist?
I mean, starting your own company is not really restricted to like the profession that you've had or you currently have. You know, it's what you want to do with your life, and if there's an idea that you really want to see in the real world, see that build up, and like what stage of career development you're in. I guess becoming an entrepreneur in itself, there's not a lot of prerequisite that you need to fulfill in order to start your own company. At least that's my take.
Okay, thank you. Yes, anybody, anyone?
Sure. So without understanding a little bit more about your question, I'm going to make a few assumptions. There are product companies and services companies. A services company where you sell your time or your services as a data scientist is probably the most accessible. And to that end, you have to go find people with problems that require a data scientist with your skills to go solve. In which case, you might find them and contract with them to solve their problem by spending hours on that problem. In product companies, you're actually creating something that people can buy that hopefully you don't really have to put more work into. They can just take it and go, right? So this would be going to, buy some Databricks so that you can use their version of Spark Notebooks and do something with it, okay? And that you have to figure out either a market need and then build some software to fill that market need, or you have to figure out some kind of technical insight where you feel like you can do something that's way better than the existing products that are out there, and you build that thing before you can go sell it. That's maybe a very high level potential answer to your question.
So, and maybe to add to that, just one more issue is that there is I see it as a hierarchy. I see on the question of how hard is it to start your job, I see it as a hierarchy because, of course, you'll have to think as an entrepreneur, you'll have to think that there is a problem that you're addressing and perhaps even eventually have maybe your work at the point as a founder or such is more of insight. Is there an opportunity to do something? Then you cease from being just the person starting the company to a person who looks at the whole cycle, the company cycle, growth, expansion, challenges that startups do have, and all those kind of things. So I think I wouldn't say it's very possible, as it has been said. It's not like it's a place that is rocked. You can be able to start, but I think you need to be aware of the cycles that go through. It's not just an issue of having a good idea. There's more that comes in the whole cycle of maturity of the product. So it's possible.
Mustafa, do you have anything to add, Mustafa?
No, I actually benefited from that, yeah.
Okay. And then lastly, another question that I have is the level required background is possibly different for different kind of artificial intelligence and machine learning related roles. But in startups, there is often great flexibility required and people might frequently take on tasks outside of their core. How does this relate to the required background? One.
Could somebody repeat the question? I was really breaking up and I didn't hear it. I'm sorry.
Okay, I can repeat again. The level of required background is possibly or likely different for different kinds of artificial intelligence and machine learning related roles. But in startups, there is often great flexibility required and people might frequently take on tasks outside of their core roles. So how does this relate to their required background?
Okay, let's see. Maybe I can answer this question with a story. You know, in a startup is kind of the only type of organization where you get to do what you're utterly unqualified to do, and it's okay, because you just get to do it well enough until you can hire a professional to do it well. Okay, and so in that way, the startup does have the flexibility, and that's where you get to do, let's say, a simple machine learning project if you're just coming as a data engineer or a software engineer, and because there's no one else to do it. And so in that way, if you go join a startup, the range of what you're able to try, you're sort of, I wouldn't say entitled, but you'll likely have more flexibility to learn new things and try different things and still have those things make a big impact. That said, if you go into a larger company where they have established ranks of there's a data engineering team, and then there's a, you know, even like a machine learning ethics team that, you know, keep a watchful eye on the output of the models, and then you have people who design the models and the people who sort of implement the inference, and you have an infrastructure team that run it, and those are like, you know, 6 or 7 different jobs. And if you go in, you learn one of those jobs.
Yes.
I stayed there for a few years. And so, you know, in that way, that's an entirely different maybe trajectory. I don't know if that answers the question.
I think it answered. Dr. Nderu, you seem to be having something to say. Dr. Nderu?
Yes.
Can
Yes,
someone explain the question again? I'm not really sure what the question was asking.
The question is, we have different level required for different kinds of artificial intelligence and machine learning related roles. But in startups, there is often great flexibility required, and people might frequently take on tasks outside of their core role. How does this relate to required background?
Okay.
You
So,
get me?
so yes.
Yes. Go ahead, Dr. Nderu.
So I think just to anchor in what Cheng has said in relation to the question of opportunities that are provided in you exploring areas that you are not. So areas. So when you join a startup, you, of course, as they said, you will have to do a number of jobs before they get somebody competent enough to do that. I see that as it's an opportunity, especially for startup, and that's why there's always advice that when you're starting your career, perhaps the best place to be in is in a startup environment, where maybe you'll find yourself being tested in various areas, and then you can set on what good you are at in that setting, and then you can work there. So when you're starting your career, perhaps is the best. So it works. That flexibility can give a person who is joining the industry an opportunity to try and test various parts of the whole development or various sections and see what they are good at. But when you join a traditional, well-established company, so you go there as an ethics AI person team, you join that team, and therefore your work is geared towards what we are looking at in creating models that in model interoperability, explainability, and all those kind of things. So eventually you may find yourself caged. If you're not talking about a person who has settled, you might find yourself caged in that area. And therefore, I see the startup environment gives a young person, and this is, of course, why I'm saying this is more or less because of also the background. The people I'm dealing with are people who are coming in, young people who are finishing, and the experiences that they need to get. Startup is a good opportunity for them to be able to be exposed to various tools and various ways that things work. And then that flexibility is interesting for them. Thank you.
Okay, thank you. I can say, Bastian, you have some insights to add? Maybe, Bastian?
Yes, hi, thank you. Yes, okay, so we have had a lot of agreement here about the need for background knowledge to be a good applicator of AI or machine learning algorithms in particular. Almost too much agreement, I would say, for a good panel. So that maybe, well, I've been a bit responsible for setting this panel up, so I take responsibility. And I'm usually, I'm usually very agreeable to that. That is that some solid background is required, also from our own experiences. But I would maybe challenge here: are we maybe just lacking a good layer of abstraction? Like, I mean, all complex systems are built on layers of abstractions that get more and more concrete or more and more technical as you go down. So in modern software engineering, the frameworks that you work with nowadays, they are quite high level. And to build a great web app, you don't really need to understand much of the von Neumann architecture, for example, that every computer is running on. So yeah, I think there's maybe there may be cases where this is more required, and then there are cases where it's less required. And maybe in machine learning, we are just getting there of getting these tools that allow us to stay on a high level and not dig too deeply. So PyTorch, for example, is set out to be much easier to use than TensorFlow, for instance. Okay, I guess as they are progressing through their versions, this also changes. But yeah, are we maybe getting there soon with some of these newer tools where people actually need less of that background, where maybe we even get tools that can tell you whether a model is of high quality or not without you understanding exactly how the data looks like, etc. Yeah, what are your perspectives? And maybe that question goes to all, actually.
Yeah, I actually have pretty strong opinions on this. Is that I think with a lot of these tools that can help you, it actually strengthens the arguments that people should really get good at their craft. Because if you look at web development from 20 years ago, maybe, people who does web development are quite specialized, and then that's a highly requested skill. And now you can find all of these builders, no code platforms, like anyone can build websites in seconds. And that's probably is, you can see the trend for AI as well. You can use a lot of platform that will be no code or low code. You don't need expert understanding of mathematics or machine learning mechanisms to be able to use them. But then if you really want to get good, then you really have to understand the background and all the inner workings of this to become an expert in the field. Like say these days, if I want to do a video, a graphic, some basic graphic design work, I can also go on Canva. So if you don't have a specific set of skills that can make, really well done videos, why would I hire you? I would just do it myself using all of these platforms that can give me all the information in a very, public, accessible ways. So that's at least what I think. Now the background in this or training on this specific domain, if you want to get good, is quite crucial.
Thank you for that. Mustafa, you have something to say? Zakia?
Yes. So I've been learning algorithms lately. So just teaching myself like what goes around when you do a dot sort, or when you there are different sorting algorithms, like more than 4. Yeah. So it's like it's very much different if you just do a dot sort and then now just do the whole sorting process on your own. So I think it's very crucial also to understand what's happening behind the algorithm, because someone came up with it. That's why it's much easier for you to do it. Yeah, that's how I view it. So I've been learning and looking out for, learning new algorithms every now and then, just not using the short forms that are available. So before using that, I make sure to understand what's happening behind. So, which is very important. Yeah.
Bastian, I think the fact that you are asking the question is a sign of the times. Like I'm by my background, I'm a database guy. And I think maybe 5 years ago, there was a question of, do people using application frameworks like Django really need to learn SQL? Okay. And if you ask a database guy that question, the answer is absolutely. You can't possibly know what to do when things go wrong if you don't know SQL. But then I would say, it's increasingly so that for moderately sized applications that using the ORM, the Object Relationship Manager, is good enough as long as it doesn't go wrong. And so if the percentage is high enough, then you're probably fine. And I think that same framing potentially applies to machine learning with a few caveats, is that there's starting to be efforts to do model generation and inference all in one go. You don't really have to understand anything. You just kind of treat the whole thing as a black box. And if you apply software engineering principles to it, you might get a good result. The problem is that if you don't get a good result, you don't know what to do to fix it, because you don't know how to introspect what's inside. And a lot of these generation frameworks, as like the let's say website building, right? Like the code that's spat out by these auto website builders is utterly unmaintainable, except for by that same website builder, right? Imagine what that code looks like for auto ML, right? And so the explainability issue, which is already an issue because you have to build trust, becomes compounded when you do generation. But that said, like I can go on Upwork and hire a Webflow developer to cobble together a website in a much shorter amount of time than otherwise before, or WordPress or Squarespace. And that's a good thing. And maybe there are use cases for that in the future of machine learning. But if you're doing something that really matters, if you're making decisions that really matter, like that impact people's lives, like a credit decision, a healthcare decision, I wouldn't trust any of those new tools until they're proven to be 99% effective on use cases that don't matter.
Thank you, Shen.
Just a follow-up on that, a simple one, a very short, simple follow-up. We this area of engineering areas, whether it is data science, whether it is whether it's software engineering. They are not new areas as engineering. We have construction engineering, mechatronic engineering. Those are fields that have been there for a substantive amount of time, right? Those areas are mature engineering field, construction industry engineering, mechanical engineering and all that. And the question would be, can we have, because they are there, can we say that they have created models that are enough that anybody can go in that area and borrow those models without understanding the details about mechanical engineering, electronic engineering, and all those kind of things and be effective? So I think for me, if I use that kind of analogy, I find that even if we are moving towards where now some of these jobs are done automatically, and even a farmer just need to have data, feed it to the model, and then you can get results there. Those tools, you will find that they work for the problem that you're doing. And I've seen them used mostly, I would say, for toy problem. As we go ahead, they're of course becoming more serious in terms of the way they are used. But well, maybe I would say that there is that caveat. How well does it work before it breaks? And that understanding is important.
Yeah, I agree. But I think from that, like if then that requires the people who can inspect the system and who can tell whether that's good and build better system to have more expert knowledge than whatever automated tool there is, right? So that actually requires people to have a background that's deeper than just doing a crash course for 3 months on machine learning.
Thank you, panelists. Thank you, panelists, for your super elaboration. I will request that we take minimum time explaining. We only have 19 minutes to go, and I can see we still have some 3 more questions. So, and to my next question, for those in startups, how do you incorporate data privacy in the system you are implementing? Chen, kindly.
This is not a short answer. I would say you have to start with a principle that the data belongs to the people that you collected it from. It never belongs to you. You might have a consent to have a license to that data as long as you're doing some good. Okay. Now it gets a little bit complicated if you want to in machine learning, if you want to keep training data. Okay, and so having a strong scheme for asking for and then being able to keep de-identified data, where you could provably really not identify the person who contributed that data so that you can hang on to it, right? That's a really tricky thing because there's tons of papers that are being published. There's a whole field of computer science that's just devoted to saying your de-identification is terrible. We can still tell who this is. Okay, and so it's a struggle, and I would treat it no differently than any other part of responsible software engineering. This is to say, rather, I would add, like recently the Kenya Data Protection Act was passed. It's modeled after GDPR, which is a good first step. I think it's a strong set of rules, and the exact legislative enactment is still to come, but the threat of enforcement is now there. But my take on it is that it's not a set of protocols. It's not like HIPAA in the US. It's not like ISO 27001 as an international level. It's certainly short of what the US government would require. They have a whole system of policies and procedures, right? And so, for example, the DPA doesn't tell you that you can't have USB drives in your company. Well, should you have USB drives in your company? Because that's the source of data privacy leaks. And so adopting a framework for the policies and procedures that you believe based on your own conditions will keep data safe above and beyond the DPA is actually quite necessary for anybody who's doing this kind of work.
Thank you. Leila, shortly.
Yeah, so I guess the bare minimum for a lot of companies here is you have to be compliant with the law, whichever country that you operate in. That's sort of the basic that you go from. And then on top of that, I guess comes from like we're a product company. So when we're deploying product to our customers, it comes from a specific set of requirements that's coming from them. Like say we work with a lot of healthcare companies and financial institutes. So they have very strict requirements, like organizational wise or industry wise, when it comes to privacy and security of their data, what can be processed, what level of access everybody can have. So that's sort of what we're working with. And then on top of that is what we believe in is best practices. But at the same time, I also believe privacy is dead. That everybody has access, all the big companies have access to everything now. We can't really avoid it, but it's about giving users power at the end of the day to know how your data is being used and if it's being used against you in some sort of way, right? And this whole cycle of if you're getting some database decisions in the day-to-day interactions on the internet, anywhere, that you need to know that how this data is being used, and then if it's being used against you, if you don't want to be used, how can that be managed? But I guess that's a really hard question to solve that we're so only just sort of getting into it as part of the product that we're building when it comes to responsible AI and responsible innovation adoptions for big companies. It's tricky for us. We can only apply, kind of adhere to the rules that we have set for ourselves, but not for others.
So I think Bastian wanted us to disagree, so I'm just going to throw some disagreement out there, if that's okay. I think about the world in two ways. You know, one is information security theater, where your legal department might want you to get a piece of paper that says we're compliant. And what I would say is that that is woefully inadequate for what we actually have to do in actual information security in terms of the policies and procedures that guard your organization, because the way that your organization works, only you know, and that the safeguards that you should take go way beyond the security theater of being compliant with any particular framework, because it is possible to do very little to get compliant with some framework, because it takes a deep assessment that in a lot of places isn't done to actually know if your data is safe or not. And it takes organizational will and leadership to actually make the data safe on behalf of the people for whom you're the custodian of the data.
Thank you, Shen. Dr. Nderi, you have something to add?
I think as a bare minimum, just one or two statements is that at the bare minimum, small companies or companies that are starting up, perhaps at this point they have not been able. Following up the bare minimum on what is written would have been enough. But as you can see, there is more demand for privacy for bigger companies and all that. So I think the way I would put it is that at the bare minimum, perhaps you can follow the written down rule, but I think awareness across the board of privacy issues and awareness of what users need to know, about their data and how it is being used is becoming very important. And you have seen that happening in Facebook, that happening in Google. So I think as we go ahead, as a company grows, it's a principle that needs to be ingrained in their philosophy.
But I think one part of it that's really hard is that if you look at the bigger companies, they're under more stringent scrutiny from the public, so they might care about this, not because like intrinsically they value this so much, so they will care. But if you look at a smaller company, because we do responsible AI software and we talk to companies of all sizes, and smaller companies, if you look at their missions and then the values that they have, it's all about, oh yeah, we want to make everything more inclusive, and this is part of the core values that we have. But when it comes to actual implementations, they're pretty much cash and time and resources constrained. So like if you look at the priority list that they have, probably smaller companies, like we're just trying to stay afloat. And then this data privacy and security issue is really not on top of the list to help us maintain like on top or staying afloat. So like there's sort of some conflict there to say, yeah, we want to adopt this organizational principle and implement all of these things in place, so we're more ethical and more responsible, and doing much more for the users that we're taking care of. But often that's not really the case in reality, from kind of just my observations.
Thank you, Lita. I can see Rahul has some insights. Rahul, you're welcome.
Yeah, I wanted to add to what Leila said earlier, actually. So the fact that privacy is dead, I partially agree with. So what we can instead do is democratize the idea that the revenue we get from your data can actually be shared with you yourself. So if I could shamelessly plug Utu right now, so the vision we have eventually is to give you direct access to where your data is going and allow you to profit from whoever eventually ends up consuming your data. So if more companies can sort of, be transparent about the pipeline and give you permissions on where your data is going and how it can be used, I think that solves a bit of the problem, because I think most people sort of realize right now that your data is out there, essentially. So why not just profit from it a bit?
Okay, thank you so much. There is another question here. In what ways has going to graduate school augmented your skills set? What are some competitive advantages in the field?
I don't actually think a lot of schoolings is really the key here. Like getting your bachelor, getting a master, and then getting a PhD, for sure that will add to part of your skill set. But if you're asking from like a job seeker's perspective, it's not really like a hard requirement for, at least for companies that I've worked at, to say you really need to go to graduate school to be able to do like one or the other jobs. But people do look at that. I guess it's I'm not really sure for working for a particular job actually needs you to have a degree in a specific set to be able to start doing it. But that's just my opinion on it.
I think you get three things from going to a school. You get knowledge, you get the network, and you get a pedigree. Okay, and so you have to consider those two things for yourself. I feel like from a software engineering perspective, the knowledge can be gotten on your own by self-study, but the network and the pedigree is something that you cannot, and unless you go. Okay, I can tell you as somebody who's hired a lot of engineers, I don't care at all about the pedigree, especially of a master's program, because some of them are like 1 year and they're professional profit centers for these schools that just like churn them out. Okay, and so if you're going to go to grad school, make sure you know that you're going for something else. And especially if it's an online graduate school, then you don't have the network, whereas a network can sometimes be the most valuable thing that you actually get out of the school. For a PhD, I think you should only get a PhD if you're pretty sure you want to be a professor or you want to do industry research. Okay, because the only other thing that the PhD teaches you, while valuable, right, is to be really tenacious, right? Because you're expected to create a small piece of knowledge, however small, that's novel, that nobody's done before. No one else can tell you it's the right answer until you publish a paper and your peers get to comment on what they think about it. And usually they're pretty harsh. And so you develop thick skin, you develop the ability to organize yourself, you develop an ability to, please your advisor and the wider community. But if you do it too much, then you get into the research game. And you only get into the research game if you're really pretty sure that's the career track that you want to be on.
Thank you. Thank you. Anybody wants to add anything before I move to the next question? We have some time remaining. Dr. Nderu, you have something to say?
Yes, I think the question around what you gain from a graduate school and all that, I think it's something that is of interest, the way it has been posed, in the sense that we have to look at, so your needs, the needs of what you want to do as a very important guide, and perhaps even the needs of the environment where you're working from. So perhaps it's obvious that there are some careers where you are competent enough. You may not need even a PhD to be able to do that. If that is your, so that takes years, of course. It takes years to go through this process, and a lot of, and perhaps it can disorient you to an area that other areas, or show you other areas that you may not have planned to go for. So I think my understanding is that the way it has been summarized by Chen, in the sense that you have to look at what exactly you want, look at yourself and ask where exactly you want to be, because PhD gives you a perspective that you can do, you can create knowledge, so to speak. And that confidence comes from the fact that you have seen other people doing it, you have been mentored in that direction, so you can still do that. But it's not for everybody. It's not for everybody who needs that, depending on the career that you're undertaking. Yes.
Yeah, so as for me, so I have I mentor a lot of people. So one of the people I'm mentoring, so like just graduated from Code Hive, and it's like so she's working at a company called Sun Culture. So like the boss is encouraging her to go to school, and she's like confused, should I go to school or not? So I'm like, if you really like know what you want to go to school for, like exactly what you want to know, like want to do in school, then go for it. And that is like I advise her to set goals, because you might go to school just to get the paper, and that's not really helpful in any way. So that's how I see it. That's my opinion. So like going to school and then like having a goal, and this is what I'm getting out of it. Is it the networking that Kwang mentioned? Yeah, or whatever. So as for me, if I want to go back to school and then just follow that path, because I really want to be a research scientist, so I'll definitely go back and follow that path. So yeah.
Anybody has anything to add before we move to the second last question? Okay, at what point or level should one consider focusing on a particular niche as a machine learning engineer or data scientist?
So I think I would want to get to the first part of that question. At what point?
At what point or level should one consider focusing on a particular niche as a machine learning engineer or data scientist?
So I think I can start off that question by suggesting that they are just like in the education system, you can have early specialization and rich specialization depending on what your interest is. So think of it, for example, looking at there are some areas in machine learning where if you just pick that as the only area, then it tends to, it can narrow down your space on which applications you can. But this area is really changing. The data science, even algorithms and all that is really dynamic area. So you need not to be so specialized that you eventually become a person who is only held with a set of tools that will become redundant in the next few years. So I think my advice would be that, yes, specialization can be at the level of which area to use, whether it is use of them in agriculture, use of them in health and all that. It can also be whether you want to be concerned with model optimization and all that, whether you want to be concerned with ethics and all those kind of things. And remember, you do not let the other areas zip away from you. You will need to keep tabs with what is happening in all these areas. And the reason is, I feel like we have not gotten to the point where I would say that the whole data science area is fully stabilized. There's a lot of movement. So many parts are moving. And therefore, you will not need to be caged in one area. I think so.
Okay, thank you. Shan, Laila?
I feel like this is a career strategy question, where, like, should I specialize? Should I remain a generalist? And I would sort of maybe push back on the question and say the following potentially controversial thing, so I can maybe invite some more disagreement into our our so far very agreeable panel, which is, I would say, do whatever allows you to make whatever you're doing at any given time the most important thing you're doing. And if that means continuing down one path into a niche, but you're still passionate about it, then so be it. But if you got bored, then it's time to, go broader, right? Like I wouldn't constrain yourself to think about the areas, like the canonical areas of machine learning, like, inference or model building or data engineering. I would more specifically think about, can you make the activity in front of you the most important thing that you're doing? And if the answer is yes, then don't worry about it. Don't worry about that career path, because the rewards will be there if that's the case, right? And so it's a matter of your interest, and you're already special. Whatever you got to do after this talk today, that's the thing that's in front of you right now. And you ask yourself the question, can I make this the most important thing that I'm doing? If not, you better find something else. And if so, then that's your specialization right now. And then you think about the next thing when the opportunity arises.
I guess a lot of the times people don't really get to pick very specifically that this is what I'm going to work on. This is my specialization. Like for some people, yes, like maybe you think, oh yeah, I'm really going to become an expert in computer vision. That's what I did my studies in. That's what I did my PhD in. And then this is what I'm going to focus on. But for a lot of people that's graduating from school, and when you're a new grad, everybody probably knows how hard it is to find a job. And whatever that first job you can get, and whatever the content of that job is, that's probably gonna kind of dictate like your career trajectory a bit going forward. And then every opportunity then comes your way, whatever you make of it, that will kind of shape what kind of specialization in a sense that you will get into later on, right? At least that's what sort of happened to me, as I was very much a generalist, and worked a lot of different types of jobs. And just through all these jobs, kind of that's where the career specializations or a niche sort of is taking place, or it still hasn't taken place yet. I'm still very much a generalist. So yeah, I think it's okay.
Okay, so as for me, I'll say try out and give yourself time, like try out the different niches available, because probably haven't figured out what you really want to do. So like as for me, I like NLP, I like computer vision, and I also like neural nets. So I've been trying out all those areas, and I still haven't figured which one I want to focus on. So I think just give yourself time, attend conferences. I'll highly suggest the deep learning in Daba. So that's where I was introduced to so many of the different concepts. So yeah, which is a conference that it just introduces you to everything in like 3 days. And yeah, probably, and then you can figure out what you want to focus on. Exactly. Yeah.
Dr. Ndero, you have something to add shortly?
I think for me the discussion around around that, what has been said in terms of agreeing that the tools that are working for you now, you need to equip yourself with that, and then keep tabs. I think this is the advice that would work for keep tabs on what is happening, the whole spectrum of the data science, so that you don't end up feeling caged. I think that's what I would say holds true for my view of the whole area.
Thank you. I can see our time is up. I don't know, Bastian, I have one more question. Will you allow me to ask it? Only one more question remaining. Bastian, kindly.
Rahul is managing this session, so Rahul's.
Yeah, go ahead, Lena. I think a short question should be fine.
Okay. Thank you so much. The last question is automated artificial intelligence or machine learning platform a threat to data scientists or machine learning engineers like data robots? Shen, kindly.
Sure. I think it's there's a kind of a anecdote from the AI Twitter that says something like, the cutting edge of AI right now is that it can get really good at a 1-second decision that a human can do, that a machine can do, if you have a whole bunch of really good data behind it. Okay, and so the prospect of then building an AI that builds other AIs is we're probably pretty far from that right now. Is my take and my hot take, and so I wouldn't worry about it. Besides, if it really gets that big and that good, there'll be plenty of other jobs for us to watch it carefully to make sure it doesn't become the sentience that that leads to our demise as a civilization.
I I don't really particularly see as a threat. Like everyone was saying, oh, you're going to be automated out of a job. But if you look at the job, the amount of variety of jobs that we have compared to 10, 20 years ago. If you tell your grandma, I'm a product owner at whatever tech company, your grandma is probably like, what is the product owner? And, so there'll just be more type of jobs being developed if technology enable us to do more and more. And if there is AI that can develop AI, there will be, much more stuff that we can do than the current kind of a pool of jobs that we have. That's well, I think.
Dr. Ndego?
I think just to follow up what I would say is that jobs at this level, the data science is more seen as a creativity job. We when it comes to that creativity niche, I see it as something that is not under threat. Still, creativity is needed, and to strike it rich, you will need that level of the thinking of how it will work. So we are not yet at a point where I would say that you should feel threatened of your job. Many opportunities. That's why I said, of course, the area is adjusting. Some of the jobs that you will find, like what data robot is doing, some of them eventually were done manually, and all that has been automated, which is true that some jobs will still be done, but creativity level expected of the area is still going up. So there's an opportunity for the human brain, and therefore not threatened.
Thank you so much. Zakia, Mustafa, do you have anything to add?
No, but yeah, definitely not a threat.
Okay. So anybody who has any question? Anybody? Any question?
I think we should call it here, Lena, so we don't need too much into Dr. Chen's time.
Okay. Okay, thank you. Wow, wonderful. Our panelists have done very well. This session has been very informative, and truly some of the fundamentals are indeed important to understand, particularly machine learning and artificial intelligence field. We are so proud of you. Well done. Thank you. Bastian, over to you.
Thank you, Lena. So I think without taking much of a break, we can quickly transition into your presentation, Dr. Chen.
Sure. Please call me Kwong.
Kwong, okay.
Let's see, how do I, okay, share. Okay. Oh, there it is. Sorry. Do some Windows management here. All right. Is everybody seeing my screen? Or
yeah, I think it's visible.
Can someone see my screen? Okay, great. So thanks everyone for your kind attention. Today, I want to share with you lessons that we learned in developing and launching a very simple model into production. So I have a couple parts in our agenda, or not a couple, a few parts in our agenda. I'm going to talk about the background, a little bit about my current company and the problem formulation, the data that was involved, the feature selection and the modeling that we did, the metrics and refinements that we did, and then finally some bumps that we hit in deploying it to production. And then if we have time at the end, some broad, more fun remarks about Antara's machine learning strategy. So first, the background. Antara Health is a virtual first primary care service. What does that mean? It means that we use a combination of products and services to help patients improve access, improve their experience, use risk insights of like, might you get sick, how much you get better, to drive better health. That also happens to lower the cost of healthcare. Okay. The way that we do it is with a thing called health navigation. That bears some explaining because it's at the center of what our model is helping with. So health navigation, think of it as on the wheel on the left, you see all of the concerns, and maybe there's some missing, but many of the concerns that somebody has in accessing healthcare. They have to think about so many things that sometimes it becomes very confusing and it leads to inaction and taking care of one's health better. And what Antara does is that it makes all that easy by dedicating a new role in healthcare called the health navigator and making accessing that health navigator, a real human being that we employ, by the way, very easy. And so we use a suite of technologies that together you can think of as almost like a magic portal, where just on the other side is your dedicated healthcare team, starting with the health navigator, but also with virtual doctors, nutritionists, mental health counselors, and the like. Okay. And so our theory of change and the data perspective on this is that by taking our members through a continuum of care, not just care that ends at the door of a health clinic or a hospital or pharmacy, right? That we can do healthcare better. It all starts with screening, where early screening and detection of what conditions you might have, we call that the baseline. And then we take that data and we very proactively, without you asking for it, engage with you and educate you on the things that you ought to know, and definitely on things that you have to know. And that creates a set of engagement metrics. We call that our outbound metrics, okay? And of course, we make available virtual consultations. And so you can call us, you can access your health navigator, your doctor, and other things when things come up. It could be as serious as I broke my leg, or it could be something like, gosh, my kid has a runny nose. Should I take him to the hospital or should I go into work, right? And all that data together forms over time, so longitudinally, a set of insights that currently is not available in the healthcare ecosystem, especially by any one party. Most of the data that's being collected in healthcare is for billing. Okay, it's not oriented towards making people better over time. And so we've been running the service in Kenya, primarily in Nairobi, for the last 2 years. And just to jump to the impact slide, and here I'm very proudly bragging a little bit. It's working. It's working really well. We're proving that we're reducing healthcare costs by an average of 20 to 25%. The customer satisfaction is really great. If you look at the two boxes around hypertension and diabetes on the right there, I don't expect you to know natively what those measures mean, but those are world-class results in the top 2 chronic conditions in Kenya. Okay. And in Kenya, up to 50% of the people have one of the top 5 chronic conditions. And when those go unmanaged, it balloons into exponential cost and very frequently leads to financial ruin because of such low health insurance penetration. And so when we can provide that kind of impact in what is kind of a silent epidemic here in Kenya, we're really proud. Okay. And that outcome is predicated on the lower right corner, which is early detection. I mentioned the 50% of potential for chronic conditions. What we found in our first population of people that we care about, that we take care of, is that we found as Antara 3 times more chronic conditions in the membership than was previously known. Okay, and that is actually the crux of the model, so that's why I focus on that. So the model that we built is focused on the screening and early detection part of running health navigation. The premise is that we want to screen so they make sure you can run around and fight and stuff, or insurance, okay, where they want to make sure that you're not going to die sooner than you say you are, okay. But in healthcare, that's just not done. But we did, and we got really interesting and viable and effective results. And so the question becomes, how can we do it better? Okay, because as the outcome of that early screening, what we do is we put people into different categories. There's healthy people, they get one set of services, but if you're at risk, you get a different set of services in addition. And if you have a known chronic condition, you get yet even more attentive treatment and management. Okay, so one might ask, that sounds straightforward. Why don't you just go ask the healthcare providers to look at the claims data of when they went to the hospital? That will tell you if they have a condition or not. Well, we tried. So just by using medical claims, we're able to find about 54% of the chronic conditions that we eventually found. Okay, this means close to half of those conditions were just not evident anywhere in the medical history of a person. This is because many of these conditions are going untreated because they're undiagnosed. Okay, and so because we couldn't rely on medical claims or medical histories in a reliable way, we had to figure out our own solution. Okay, and so the problem statement, this is the next section. The problem statement is that we're now in the process of onboarding tens of thousands of new members. And the best chance to figure out and intervene and engage members is to figure out who has the highest risk of a chronic condition and go to screen them first, right? But screening and onboarding is resource intensive. It requires the actual screening that confirms the disease requires a bunch of forms to get filled, requires a face-to-face virtual consultation with a trained nurse, and it requires potentially labs for where blood or urine or point of care devices are brought to your home or your workplace. Okay, so that's not free, far from free. And so the business need here to then further constrain the model that we're building is a systematic way to rank our incoming members, consider a stream of members, okay? For every member that comes in, we have to assign them a rank of how likely are you to have the risk of a chronic condition, so we know who to focus on first, okay? So that's the problem. And so we pose this problem as a supervised learning problem where the input, where we do offline training to build a model, is a medical questionnaire from members that we have taken care of in the past. And it's annotated with the ground truth, which we then subsequently found because we screened everybody, if you recall, of whether that member is either at risk or has one of the top 5 chronic conditions. Okay, and the output of training is a model that can be used then for prediction of that stream of new people. Once they answer that same medical questionnaire, it gives a score between 0 and 1, indicating whether they're what is their relative risk for a chronic condition. Okay, so let's talk a little bit about the data. The data, oh gosh, I pushed the wrong button here. Here we go. Here we go. All right. The data that was available for model building were this questionnaire, like I said. The initial data set contained 602 members. I just remember 600, had about 90 data fields, okay, of various kinds. Now, like I said before in the panel, it might be interesting to think about, well, what else data might be relevant, but we just started with what was in this one questionnaire, okay? And the ground truth is reliable, I should mention, because we literally had, doctors and nurses who have the specialties and the competency to diagnose a condition, and laboratory results that confirm the diagnosis of these conditions. Okay, and you can see some examples of the questions that are there. Does anybody in your immediate family have high blood pressure? Obviously, that would give us some hint as to whether somebody might have a high blood pressure themselves. Okay, so the next step we took with this data set was we split it into training and test sets. Sometimes people will also make validation sets. So one of the central steps is to define this. We took the standard 20%, 80% approach. Okay. For evaluating the model, we're very careful to not look at that test set under the principle of no peeking. Okay. We also did cross-validation to make sure that the immediate judgments of model quality were getting better and better before we did the final evaluation. Okay. We had to transform the data. The raw data from a questionnaire might be oriented towards the user experience of rather a good user experience in entering information, but it needs to be converted into a numerical representation. Like imagine a very square spreadsheet, okay, where the raw data needs to get filtered, sometimes deduplicated, the features translated into numerical representations, and then sometimes for things like multiple choices, we need to encode those into particular classes, and then out comes the prepped data. Okay, pretty simple. The transformations include, we already talked about this. I'll just keep going. So next, the feature selection. So we have 89 columns. What do we do? Okay, and so we actually, before I start on the columns, jump to order my slides. Let's talk about the model iteration. Okay, and so we built several generations of the models, analyzed the performance metrics on those models, got feedback on what might be right, what might be wrong, and then cross-validated. Okay, I think this is all pretty straightforward stuff, but I wanted to make this maybe a more practical tutorial. Okay, I just wanted to say that there were many steps, and the iterative improvements meant that we went back and forth in these steps. Okay. Okay, the feature selections, the 89 columns. So how do we figure out which ones should we feed into the model, right? If we had enough data, and if it were like sizable enough where we could just throw it at an algorithm, let it figure it out. Now that sometimes is the convention, but we chose features for whom in which there were a good distribution of answers. So, for example, in a questionnaire, you can't just use everything because sometimes people, especially questions towards the end, people tend to like drift off and not answer those. So if you have 98% null in a particular data column, may not be a great feature. Okay, and so well distributed. We feel, and this is controversial, that these variables, these features should be intuitively predictive of the output. Okay, if it just doesn't make sense, well, maybe keep it in there for one of the intermediate iterations, but you should be aware that intuitive sense is a totally valid criteria. Okay, and because of the types of modeling that we decided to do, we also decided to cut away a lot of the noisy features and just keep 26, okay, that were well distributed and plausibly predictive. Okay, so we started very simply. Like I said, this is a very simple model. We use logistic regression. Just briefly, it's a very standard classification learning technique. It is parameterized by these weights. each feature is, and then you sort of just multiply them together, pass it through a logit function, and it estimates probability between 0 and 1. Okay. We also tried a decision tree. Decision trees are really cool because it's you just sort of take a path down this tree that you build and find a particular branching that best classifies your training data. Okay, so we tried both because they're easy to run. And really what I should say is the data prep is probably 95% of the work. Getting these two models trained up, especially simple ones, is just a little bit of work. And then the other 95% of the work comes through in what comes next, which is the metrics and the analysis. I'm just going to take a moment because I keep hearing a dinging, and I want to make sure that I'm not missing somebody trying to ask a question or something.
Oh, that's okay.
No, that's just people coming in and out.
Oh, okay. All right. Thanks very much. Thanks very much. Okay. So let's take a look at the metrics, right? There's a variety of ways to characterize the test set performance. You have a list of all these different metrics here, okay? The two that we chose were the accuracy, because it counts both the positive and the negative correct answers, as well as the area under the ROC curve, okay? Because that takes, that's just canonical. Okay. The thing here is you have to figure out what metrics for accuracy you care the most about that's most relevant to your data set, right? And so in this case, what we're trying to do is not miss people with chronic conditions. So we care a lot about recall, okay? And just holding that in mind, and that's part of the reason why we chose these two metrics. So we decided to train both and compare. The accuracy differences between the logistic regression and the decision tree models were not that much. And so based on that, we chose the model that we eventually used based on explainability, because logistic regression is very simple, very easy to understand. Okay. Now, there were the results had some expected characteristics and some that were less expected. And so, for example, the features that had a strong correlation, like, do you have a history of chronic conditions, strongly correlated with you having a chronic condition? Great, made sense, awesome. And then if you exercise regularly, strong negative correlation, awesome, perfect. That's doing well. Sometimes gender, not sometimes, but we found that gender was predictive. Interesting. Okay, that does tend to be true. But what was unexpected was that we saw a very strong feature from a field that was describe your family history of hypertension in free text. Okay. And we had encoded this feature by saying anything that's not some long list of variations of no, none, nah, blank as no, and then anything that has free text as yes. We weren't doing any like text analysis or anything like that. And it turns out we made a mistake. Okay, and the mistake was that there was this other feature that we totally dropped on the ground, where it was actually asking, do you have any one of these conditions? And if you did, it asked this other question of describe your family history of that condition. Okay, and so the lesson here is to carefully do the feature engineering, especially if it's a select many, in order to fit the type of model that you're using. Okay. And so we weren't splitting out the select many of like, select all that apply into binary columns of like, do you have this? Do you have this? Do you have this? Right. And that led to a huge omission. And so we decided to, fix that and retrain through a series of model refinements. I'll talk about that second. The first model refinement that we did was we asked a question that we should have maybe asked in the beginning, right? Which is talk to the business, in this case, talk to our clinical team. Does there exist some data that's not part of the initial training set that can be fully integrated into the data set, that intuitively will improve the accuracy of the model and can later be added to the acquisition process, even though we're not collecting it currently. And it turns out we maybe should have thought of it in the first place. BMI, or the body mass index of how large someone is, hugely predictive of someone's likelihood for chronic conditions. We were not collecting heights and weights in the initial time, but we had heights and weights available because we ended up, doing assessments on everybody. Okay, and so we decided to add BMI into the model. Okay, and then we had a very interesting discussion of, well, one thing to have a nurse or a trained person take your height and weight. Another thing to take, self-reported height weight in, through like an app or a form, which is what we were doing. And our suspicion was that people would probably under-report their weight and over-report their height because, that's what people do. Okay, and we wanted to know, is our audience the same as this thing that we were afraid of? And it turns out no. The self-reported height weights are totally trustworthy. So we've plotted, on the scatter, the heights and the weights, and you can see that they're, roughly value R value 1, right? And so that gave us the confidence that we could use clinically measured heights weights in the training data and arrange a way for us to then get the self-reported height weights from the input for feeding into the model. Okay, and so once we fed that into the model, we were able to see a great jump in accuracy. Okay, but note that it took a lot of talking, not just plotting the data in, because we had to get agreement that we're now going to add 2 more questions to the user experience of somebody getting screened that we weren't asking before, mostly because we didn't trust the self-reported answers. Okay, but the potential value is so great that we decided to actually do it. Okay. You can see that both the decision tree as well as the logistic regression model perform much better with BMI than without. And so back to that idea of recall that I mentioned earlier, right? Like our goal here is to, because of such a strong demand in the number of people that we have to screen, we wanted to order people by their severity as they came in. And sometimes we might have to, basically we have to discontinue screening everybody. Okay, and so with the model outputs, we're able to determine that using a threshold of 0.9, okay, it amounts to what we call baseline here is actually screening. Screening about half of the members would help us capture about 88% of those members with chronic conditions. Okay, that's a pretty good trade-off, right? And that's the optimization that we were hoping to make, and we got there. Okay. And then we found out that the screening questions totally changed. Okay, and as is sometimes, your training data, and hopefully not the one. The features with the most statistical power might change. And in our case, it did. And so what happened was that in order to improve usability and new user experience, we decided to reorder the way that we were asking some of these questions. And so questions that used to be, do you have hypertension? Do you have diabetes? Turned into the one that I mentioned before. Do you have any of these following conditions? Okay, as a multi-select, I mentioned that. But then we added different versions of, do you have any of these following conditions that were framed as, have you in the past had any of these following conditions? Or has a doctor told you that you've had these conditions? Or are you aware that you've been at risk of these conditions? Because our clinical team decided very sort of smartly that different ways of asking the same question might jog a different response, right? And so now everything that we trained on was misaligned, and we had to decide what we're going to do. Okay, and so we did, I would say, somewhere between good practice and machine learning hearsay. Okay, we decided to, similar to what I was talking about before, parse apart or break apart these new multiple selects into binary values and or Boolean values, and these Boolean values representing each condition, but just the ones that we were interested in, right? And so that solved one part of the problem. But then there's these other versions of these questions, like, does your immediate family have a risk, right? And we had to make a very, I would say, a very gross, like icky gross decision to say, well, if you have had a condition in the past, it doesn't quite get you to the level of risk of having that condition, but it probably feels similar to someone in your family having a condition, even stronger. And so we felt confident, although we had to hold our noses, to OR those into the question where the immediate family also, where we're asking whether the immediate family also had one of these conditions. Because we wanted to make sure that those get included. And because we care more about recall, okay, than precision. And so because of that, we decided to include that question as well. And so the broader maybe lesson here is that it's really important to be practical, because you probably wouldn't have wanted to do this in the abstract sense of building a really good model. Okay. And so we reevaluated its model after we made this change, and it turns out that the results were still really good. And so we decided to go with it, right? And so we were able to, the overall number of people went up by just a little bit that we would capture as chronic conditions, and the miss rate, went down by just a little. Okay, and so at that point, we were very comfortable with how the model was looking, and we decided to ship it. Okay, and so that takes us to model deployment. And so we had a couple of considerations so one is that asynchronous execution for inference is very important. And so, like I said earlier in the panel, the compute heavy runtimes that happen in your ecosystem, they have to be non-blocking, first of all, and you don't want them to compete for resources like on your application server or database server. Okay, might make it fall down, and so they have to be on sort of a different set of resources. We decided to go serverless, okay, to leverage existing cloud infrastructure like in Amazon Web Services to handle those inference computations on demand, and to reduce the DevOps overhead so that we don't have to have yet another set of servers that we're running to just run the machine learning algorithms. And the additional benefit is that if we use these cloud services, we get free horizontal scaling in the future. Okay, and so we have a set of we have an existing infrastructure that does that runs asynchronous workers built on AWS. If you're familiar with frameworks like Django, you might have like a Django Celery infrastructure running against Redis, in which case you're running on servers. But for us, we decided to go serverless because it sort of decreased the that particular overhead. Okay. So our deployment process, we were able to use this existing infrastructure. But we ran into a problem. That problem was unexpected in that using AWS Lambda functions to run machine learning, it has a 250 meg limit, and just the sklearn module exceeded that limit. Okay, and so at this point, we had a couple of things to try. One is we could trim the dependency down to the limit, but we kind of thought, well, we might need it in the future. Option 2 was to deploy the Lambda function in a Docker container and then using our existing DevOps toolchain to push that Docker container. Okay, so that's more like now we're utilizing our own DevOps tools. And 3, there's actually a service on AWS that I want everybody to know about called AWS Fargate, which is basically Lambda where you can specify the amount of compute and memory and stuff that you need. And so it's heavier compute engines that are both serverless as well. Okay, I think that so my apologies. Somebody has rang my doorbell 8 times, and I'm wondering if it's an emergency. This is so awkward. I'm just going to be right back. I'm so sorry.
So, and then you posted the
Okay.
comment in the chat. You want to talk about that? Or you are asking Kwan to do that?
Hi, sorry about that, everybody. I'm back now.
No worries.
So maybe just a bit more about our machine learning strategy in the quickest possible time, and then we'll get to our questions. So we managed to deploy our first very simple model. It tackles the very first problem in a long chain of steps in the way that we take care of people. Okay, I want to explain it to you, and that we have a lot more work to do, and we're definitely hiring, and so please come visit our career site. The way that we at Ontara think about machine learning is to take a data-centric view of human workflows, in our case, healthcare workflows, where we're not talking about any particular disease pathway. We're not even talking about a particular role or domain, but we see all clinician decisions as micro decisions, where analog data of some kind comes in, that gets converted into raw data, usually in our heads. We might clean it to make it regularized. We might validate it by, let's say, checking an ID of somebody that came in against a database to see if this patient is a registered member, for example. We might enrich it. We might reach out and find, based on somebody's identity, their height and weight from somewhere else and put it into our model. And then we make a decision, right? And that decision could be a prescription, or it could be to call you back later in 24 hours versus 12 hours. Okay, all these are little tiny decisions that get made. And then somewhere down the line, there's an outcome. And that outcome could be whether you have a condition, whether you got better in your condition, whether you stayed alive. Okay. And the idea here is that the way that we visit Facebook and Amazon, every click is tracked, and they use that click trail to predict which ads we ought to see to maximize profit. We want to record all of the decisions that a clinician does in a similar way, and using similar mechanisms to make sure that that unrecorded knowledge that would hinder both visibility and decision quality get recorded, so that the best of modern data science and machine learning can be leveraged to help healthcare. Okay. And so the way that we think about these decisions is in a loop. Okay, because healthcare decisions are really important. We don't and may never trust the machine to make these decisions for us, except for when it's for things like ranking and prioritization and convenience to start. Okay, but the way we think about that human in the loop design is that there is some set of data based on actions done by these clinicians, like we did with the survey. Those we can make into machine predictions that we integrate into the user experience of these clinicians so that when they make their decisions, they're either hopefully guided by the prediction as well as they can correct it. And whenever they correct it, then we have better training data for the next round. Okay, so this iterative loop requires designing the output of models that may or may not be ready for prime time into the flow of work in a way that's controlled and measured and responsible so that we can make more training data for later. Okay, and so we're just getting started here. But in order to integrate that part where the human guided decision is based on machine prediction, we have a few thoughts. Okay, and we call these Antares principles for integrating machine learning in healthcare, which is don't try to replace a doctor. That's not even written down, that's just assumed. Okay, don't try to replace a doctor, but rather contextualize decisions by giving the clinician everything that they might need to see, including the predictive value, so that they can, in one interface, make a good decision. Okay. And in that interface, when they have all of the context, give them a prediction of what you think they're going to do. Okay. Make what would have been maybe like 5 clicks or a little bit of typing into 1 click. Yes or no. That's the course to take. But give them the rest of the context that they needed to make sure that that's a good decision. Okay. And if we can do that, then we can then get their agreement or disagreement with the prediction as a piece of new training data. Okay. And then finally, what we can do is we can route particular tasks to the most appropriate person for resolution so that we're taking advantage, perhaps based on their success rates, right? We can take advantage of the different human capital that's in an organization, right? This is the same way that I used to build the previous my previous company, where we specialized in handwriting recognition, and we've sort of borrowed and adapted it to here in terms of building ML models in healthcare. Okay, so final meme slide, and I'm done. So we have a vision for how we're going to automate the health navigation part of healthcare. We think that this is an amazingly important new role. And so where we've started is with rule-based automations, where these are basically triggers, okay, based on particular static rules. We have over 100 of these triggers running in different times and places off of events, off of time triggers, to make sure that the process of health navigation moves forward. And the nurses literally don't have to do anything but FaceTime with members when they need it. All of the other mundane stuff is taken care of. We're starting to do interpretive work where the analog inputs that come in that need to get turned into raw data. There are many wonderful libraries and companies doing interpretive machine learning that allows data to be extracted out of PDFs or handwriting, chatbots to figure out intent, calls that can be summarized. All of these interpretive things we can use as incoming signal. Okay, but it doesn't quite solve the full problem. Where we started and where this model that we just launched lives is in the area of what I would call a cognitive automation, which is under the flag of where I've bolded, it's a statistical member categorization. What we additionally want to do is to then generate key events for when somebody should reach out to someone. We want to make suggestions based on decisions that get made. We want to make suggestions for which intervention should someone make. So let's say you have hypertension and you're also a little bit obese. Should you lose weight first? Should you increase your activity first? Or should you cut your salt first? Okay, and based on different parameters, that answer could be different. There are clinical workflows for that, for sure. But in a multivariate way, we believe that that decision can get lower variance and higher quality if we had a model in the loop. Okay. And so then with these 3 tiers bundled together, we have this vision of automating health navigation, where we see a chain of these rule-based, interpretive, and cognitive automations working together on a decision threshold that's very carefully monitored, so that, let's say, a good proportion of decisions can be made automatically, while our exceptional humans are there to do exception handling and sampling-based audit of the results, so that they can even further spend their time doing what they're needed the most to do, which is to do face time with their members. I'll stop there and see if there's any questions.
Thank you so much, Quang. Guys, please get in your questions on chat.
There's already one question, Raul, in the chat.
Ah, yes, Dr. Lawrence Anderu. So he wants you to comment on automated data gathering versus using questionnaire.
Oh, I see. Yep. Yep, we could definitely do some automated data gathering. I think that that's expensive sometimes. For example, everybody could get one of these. It's a Fitbit, okay? And if we had everybody's step count, we could definitely have a good idea of what activity is. But when we look at our membership in Kenya, the likelihood of everybody having a Fitbit is lower. Doesn't mean it's impossible. We do some automated data gathering in terms of we send blood pressure cuffs and glucometers to our members' homes to make sure that they get measured when it matters. But you're absolutely right. We could find high quality data signals. For example, in the claims data, that's where we started. It was in the medical claims data. We thought we're going to get all the answers, and it's not there. And I'm a firm believer in having built the models that we've built in my career. Like, you kind of have to generate your own training data. In my last company, we crowdsourced 1 billion pieces of handwriting, cut down into individual words of different types and forms. And with that 1 billion pieces of crowdsourced and verified handwriting, those labels were what gave us the ability to read handwriting better than people can. And I'm somewhat biased in that I feel like a lot of times you do have to generate your own training data. But thank you for the question, and I agree with you.
Go ahead, Bastian.
Yeah, thanks. Thanks, Quang, for the presentation. Great stuff. Really interesting. I was intrigued particularly by your comment on that you have this requirement that features need to intuitively make sense when it comes to whether they should have an influence on the outcome. And it reminded me a bit of that old fact, or often quoted thing. I don't even know if it's really true, but that the number of times that Nicolas Cage appears in films in a year is highly correlated with the number of people who drown in their own pools in the same year. So that's often cited as an example that correlation is not causation. True. So there might be just happenstance at play here, but then there's also the perspective that, okay, data alone doesn't tell the whole story. It's also the story behind the data that is important, whether something should have actually influence in predicting something. And that's the whole basically causal inference idea of Judea Pearl and others. What's your view on that? I think from my understanding, maybe such a causal model inclusion in your whole pipeline and overall model, so to speak, could help with explaining this intuitive step, making it a bit more formalized. So I don't know, maybe we want to hire some people that can do some causal inference for you as well.
Yeah, that's a really good question. I think that first of all, as a foundation, like for the audience and what the audience might be interested in, like if you can get a really good grasp of logistic regression and decision trees and just linear stuff, but you really know like the math behind it, and you can debug it, you can sort of run circles around it in terms of applying it to different problems. Like, you're already there with I would say 80th percentile of industry. This is all to say, we don't have to get complicated in order to get great results, because these mathematical foundations just work, and they're simple because they're intuitive, but they limit us, right? So for example, we can't just feed height and weight directly into a linear regression model, because it doesn't have the mechanism to understand that if you put them through an arithmetic function to arrive at BMI, BMI becomes highly predictive. Okay, we have to do the feature engineering to make a BMI number first before we feed it into a logistic regression model. But if you were to use a different type of model, slightly more sophisticated, that can take into account kind of like the polynomial relationships, then you can definitely kind of like let the model have at it, if you will, right? And so when we consider where we're at, we could certainly collect a lot more data and feed it into a more sophisticated mechanism without doing a lot of the evaluation work. We could go into, let's say, like a PCA analysis on the features, or even we just throw it into deep learning. Those are all possible steps. We haven't gotten there yet. I feel like we can get a really good result with a linear regression model that's utterly debuggable. Let's get there first and see what else we have to do before we come back to use fancier methods.
What I'm hearing is you're suggesting people to take some economics courses along with their machine learning classes to get some causal inference. Yes, there's one more question. It's by Matt. Are there hospitals that are willing to share their data for training?
The answer to that is it depends, and we have to get permission. Okay, we have permissions from everyone. Oh, am I coming through?
I think my internet connection's bad. Never mind. Go ahead.
Okay. Yeah, I think I got the full question. There may be, however, the way that we look at it is that the hospitals and the insurance companies may or may not be the owners and the custodians of this data, and we always have to get permission. So that's something that we are working on. And if we can get that to work, we will be better off for it. Absolutely. Yeah. So it's a great question.
I think I also have a question. So in terms of gathering data and collecting data, how do you sequence the questions that you send out to your customers? Because as you mentioned earlier, by the time a participant reaches to the last 5 or last 2 questions, they already have some sort of fatigue. So do you add weight to particular questions more than others? And there's a second part to this question. So how do you compromise between dimensionality and explainability?
Yeah. So to your first question, like question ordering is definitely an important topic. I actually wrote a paper about this in grad school. The idea is that some questions have good information gain. And so if you measure the information entropy of a question in relation to the other ones, you'll be able to, let's say, ask the most valuable questions first. Okay. The problem is that from a survey research perspective, that may not make sense, because you kind of want to cluster the demographic questions together with all of the other, like, do you have one of these conditions questions, right? And so you're really kind of like taking whole groups of questions, like information gain, into perspective, and you can rank these groups, right? And that actually has some movement as well. And you also have to consider, in terms of survey research, sometimes asking demographics questions can be a priming factor. So this is like, psychology, if you will, on the quality of the questions you get when you're asking about healthcare. And so there's a lot of, survey research, and especially survey research in a data-driven way that cares about the quality of the information that you're getting, is a deep, deep field with a lot of ink spilled, trying to figure this out. Okay. On your second question, I would say that we are working with clinicians who were taught and trained that they are literally the captains of their industry, and the person who's saving a life, right? You're going to tell me a computer is going to tell me how to do my job. So we err towards explainability as a default.
That makes sense. Thank you so much. I think there's one last question before we get into the break. Matt again is asking, will something like federated learning help with the privacy barrier?
I have no idea what that question means. There's two individually, the words make sense, but I don't think I understand what a privacy barrier is. Could someone help me?
Matt, do you want to comment on this yourself?
Hello, can I speak?
Yes,
yeah,
please.
Go ahead.
Oh, okay. I meant like if we like use something like federated learning in the hospitals themselves or something like that, like can does it uh get rid of the step of having to ask the hospital for permission to use the data to train or something like that?
Yeah, I think that's an interesting idea. If I had to rank the difficulty of getting a hospital's IT team to set up a machine learning application on premise is probably somewhere higher than the difficulty of getting their legal team and their chief medical officer to say, yeah, you can have a de-identified copy of this data. And so it may not be worth jumping through that hoop, but I appreciate the idea.
Makes sense. Thanks.
Thank you so much, Quang. This was very insightful. I myself have learned a fair deal during your presentation, so I appreciate it.
All right. Thanks, everyone. Have a good rest of your day.
And we have a 15-minute scheduled break right now. So we'll see you guys back in 15 minutes. I'll put up a counter and then we can continue with our talks. Thanks, everyone. Okay, welcome back, everyone. Hope you all are ready to get started again. So the next part of our agenda is a talk by Mutembe Kariuki. He's a part of Ioni.ai, and he's going to be presenting on customer service with conversational AI and data analytics and its challenges in Kenya. So a bit of introduction first. Mutembe Kariuki is a Kenyan tech entrepreneur working to bring the benefits of AI to solving challenges in Africa at a startup called Fastager Inc. His interest in technology, entrepreneurship, and leadership development has led him to work in organizations in various countries like Kenya, Austria, India, and Japan. He also spent his time learning about emerging technologies such as the Internet of Things, 3D printing, that he believes will radically improve the quality of life for humanity. Mutembe holds degrees in economics and information systems. A fun fact is that he has been a part of a social reality TV show called Imagine Africa that took him to South Africa, Mozambique, and Rwanda, and was broadcast in over 40 countries as part of an African media initiative to combat HIV/AIDS in Africa. Welcome, Mutembe.
Thank you. Thank you for that really nice introduction, Rahul. And I'm excited to be part of the City.AI conference. And so I'm not very much on the technical side of talking about models, but I'm just going to really share more about what Fastager has been trying to achieve and how we ended up working on Ioni.ai and the challenges that we encountered in the process. And it wouldn't be so much of a story of success, but more like the challenges that we've had. And I hope it's helpful to anybody else who's like looking into this space. So I'll just share my screen and ask if you all see it. Okay. Yeah. Can you all see my screen? Okay.
Yeah, we can see it.
Perfect. Okay, so Fastager is a startup focused on democratizing AI. So just give a quick introduction. Great team of co-founders. The co-founder who's working on finance. All of us met here in Kenya, but working from different parts of the world. Stephanie is working from Stockholm, where she's been working with companies such as Klarna. Jude, our CTO, has a background from the MIT Media Lab as well as Georgia Tech, working particularly on climate models. And then there's myself, who's been working in the Kenyan ecosystem in the tech space for quite a while. We also have a great group of advisors from Todd, based in Silicon Valley, Abi working for Nubank, and Sia Kagatapaki here in Kenya. And so the problem we sat down and were thinking a lot about is how, and I've had this talked about by Kwang as well as Leila about sometimes the lack of data sets, right? And this was I believe this was last year, where there was a model that was designed to clear up blurry images, and when it was given a picture of the original picture, which I think most of us can tell that's for President Obama, the output was what you get on the left. And primarily this is because of the fact that it didn't have representative data sets, right? So that it could actually come up with a better idea of what it's coming up with. And so we particularly decided to focus first on, creating data sets for African use cases. Starting that business based on, seeing how Africa risks missing out on the benefits of AI due to the lack of training data sets. So whether you're talking about in the health space, one of the projects we are working on is on as Leila has mentioned, skincare. We had talked to a university in Switzerland, and they didn't have enough darker skin tones to come up with an accurate model. In agriculture, we looked at, how do you combat climate change with the different topography in Africa? There are not enough trained data sets with African focused satellite imagery, again in infrastructure, and primarily African languages. So use cases such as media monitoring, and as I'll come to talk about, customer engagement. So I think this has already been mentioned before, the potential of AI. And so we decided to focus on, the fact that Alice, she can be an AI manager at a company implementing AI, but one of the biggest challenges is, lack of capacity to, create those label data sets for her use case. And so as Fastager, we decided to start from the side of, helping with data preparation. We all know how much data is usually needed for example, deep learning. Especially if it's images, it takes a lot of people to do that. So we saw an opportunity there, and we started first from the space of creating training data for companies. We've been doing it for a couple of companies in the US, in South Korea, as well as other markets. So we've done over 300,000 tasks to date. We worked with about 100 young Kenyans who've been able to make an income doing this. And we see that this as a continued opportunity. Companies such as Google has also got into this. And we have a platform where we do this data labeling. We find that it can be done pretty well on the African continent. And so, yeah, so that's a brief about Fastager. And then now I'll go into Auni. So Auni means assist in Swahili. So this is the Kamusi version of Swahili. And so what we were working on is we looked at what use cases are really interesting in the business sector, globally and also in Africa that could be used. And so we saw that, building an infrastructure for finance and e-commerce SMEs to engage with their customers well, whether it's in finance, talking to your bank, engaging with them and having the right answers at the right time, or if it's e-commerce businesses, for them to manage the inundation of customer engagement, especially during the COVID pandemic. We've been having a lot of people going online and they have to manage their conversations there. So we looked at the fact that the problem is that SMEs are overwhelmed by customer engagement and cannot automate to derive value and insights from all the engagement and the transaction data. So in this case, you have, which is a reality that most of the e-commerce businesses are actually owned by ladies. And, you have the fact that she decides to go online, right? But, the question is, will she be able to, if her business is doing really well, handle all the requests that are coming in? The payment data, if someone is asking, do you accept Visa? Is it everybody should be answering the same question? And so we decided, okay, how do we come up with a suite that can be used by this e-commerce entrepreneur? So coming up with a multi-platform personalized customer engagement system that will enable them to analyze the data, onboard users, answer queries, upsell products, and optimize logistics. So in this case, we would be using, the idea is, I had a lot of questions around, startup, building the startup. So in this case, it's how do you use machine learning and AI, conversational AI in particular, in a business case such as this, to help the customers. And the primary challenge that we saw, even when people have been trying to automate the messaging is usually very generic. It's, usually just everyone gets the same kind of message, so you have low conversion. There's not much of picking out information that you've sent over time as a customer and being able to remember that and prompt you at the right time to buy the same product or something complementary to that product, or knowing that a certain person is usually buying, let's say, their groceries every end of the month. And if you want to do retention, is you send them a message and saying, they have a discount the next time they use it. But you're finding that most of the customer engagement, particularly on the continent, is very generic. And again, we interviewed over 100 businesses, through different engagements, one with KEPSA, and trying to learn, what would people want if they were to come up with such a system. So that's just one thing that I would definitely advise anyone who wants to build something that is, you'll be talking to businesses or customer facing, is, as you're doing that research, you try to find out what people want. And we realized that a lot of people in Kenya wanted a model that could actually pick out Swahili, because a lot of their customers will be asking questions mixing language. And so part of the opportunity we saw was in social commerce. Retail e-commerce grew, 36.7% to about 85 billion in 2020. That's primarily driven by the pandemic. African e-commerce sites had about 2.2 billion hits in 2019. And so this shows that there's a lot more increase. A lot of the models that have been built, there's a lot of, chatbot models that have been built, or conversational AI outside Africa, things like Chatfuel and others that are used by other e-commerce platforms such as Shopify. But you'll find that most of the time, if you go to use them, if you're a business on the continent, based on the companies we've talked to, is you'll find, you click on it and you're told does not support your region. So realize there's a need by e-commerce entrepreneurs who are selling on social formats platforms such as Facebook, Instagram, Ping Me, or all the other, or Pigyami and other platforms like Rupu and OLX, or the others that have existed in the market. And they can't automate. They have to have someone who's always there answering the questions. Then the other thing we notice is, so Kenya alone has about 1.5 billion e-commerce market in 2021. 7.4 million micro and small enterprises, and a lot of them are being pushed to go online. Most of them are the persona of the entrepreneur is usually a female social commerce entrepreneur between 24 and 45. And WhatsApp is the most used messaging app for most of these interactions. And right now, you mostly have the canned responses on the WhatsApp business app. However, it becomes very difficult to get access to the API to automate these conversations. So the customers we eventually zeroed down on were online businesses, and interestingly, influencers. Because one of the interesting things that we realize is that influencers get completely inundated by messaging. Let's say you're an influencer, you're marketing a cosmetic brand for a certain company. The challenge is, if you have, let's say, a following of, let's say 20,000, 100,000 followers, right? And you've curated that following who would mostly be interested in the things that you're interested in, and you're promoting this brand. And just imagine how many messages you're getting when you're promoting a certain product. Right? And a lot of them are not able to manage all this. And most of these people, since the influencer themselves is not the expert about the product, yes, they know most information about the product, but now the customers, the people who are being marketed to, want to ask questions about the product, that might not have been in that promotional video. And so we realized this is an interesting emerging market of people. And a lot of times, people still use local language for these conversations. And that's a challenge on the continent. So we decided to come up with, to test out whether, people would be interested in an AI-powered customer insight and engagement platform for e-commerce. So we put out the platform and we tried to see how many people would actually be interested in setting up. Surprisingly, not as many people reached out to try to set up this system. So we realized there's also a lot of education that is needed for the customer to see that, yes, they have a problem, but somehow they've been getting by. So would they be willing to pay for something? And the way we were thinking about it is to work on actually not just having a chatbot, but actual conversation. So this is an example with one company that we know that, how they've set up. So, you can have a normal conversation. The good thing in Kenya, since we have M-Pesa, you can have most of the, conversations happening on WhatsApp. So the setup was to get access to the WhatsApp API and enable businesses to actually have a complete conversation, have a repository in the database of special offers that can be sent to the clients, right? And so they can have a natural conversation, some sentiment analysis to understand what the person is asking for, and then send them messages. And the good thing is why we were focusing on WhatsApp is that WhatsApp, the good thing about it, as opposed to having on your website a chat link, right? That means every time someone has to come to your website, but with WhatsApp, it's always on the person's phone, so you can be able to engage with the person. And I think that's why WhatsApp is so powerful, and they try to control the API a lot. So the way we structured it for the business is that the business would be able to see the conversations from the different people that they're having. Yes, you can have this and see that on WhatsApp, on your WhatsApp business app. But the good thing is, if it's on our dashboard, they can be able to correlate, the transactions to knowing, who has paid and when they've paid, and then be able to do a basic data analytics that then they can be able to re-engage the customer. So then they'd be able to get a good understanding of the conversations that day, the revenue, the retention, and this is the dashboard that we are building out. So the solution flow that we're building is that the conversations and insight engine would be able to taking information from M-Pesa transactions, and then M-Pesa transactions would have the individuals, basic data, what they've bought, how much they've bought from you, and the channel that they started engaging you from. And you'd be able to now optimize how your campaigns would be on the different platforms. And the whole idea is around micro engagements. How do you use this data to now automate continuously engaging that customer by being able, but of course at certain times, rewarding them for their loyalty, sending them discounts, but that is tailored to them. Because I'm sure a lot of us already, probably downloaded an app from certain supermarkets and others, and or you've given your number at some place for WhatsApp, and you just keep being sent the most random messages about any offer they have. It's nothing has been tailored to you. So the whole model is around, getting that transaction data from an engagement data, whether it's particularly through WhatsApp, activate that particular customer, measure, refine, and then engage them again. The way we were looking at this is that, we'd be able to get good locational optimization for deliveries, because we realized the customer engagement experience for any business is right from how the customer first finds out about you as a business and your product, all the way to delivery. So if you don't get good delivery, then the customer is still not satisfied and might not want your product. Sentiment analysis based on local language and context and understanding. That's where now conversational AI and working on that comes in, particularly for this region. And understanding the frequency of payments, so that's a bit of data analytics there. And then time spent in product and basket mix. So some of the people we've been working with so far is Kepsa. And now that's I'll start going deeper into the conversational AI and how we've been trying to build that out. So we got into the NVIDIA Inception program, and they have access to GPUs, and particularly they have the NVIDIA Riva pre-trained stack for conversational AI. It's pretty good, especially for automatic speech recognition and text to speech. But also basically, this is if you're eventually going to do like call centers, but just generally for text. But again, it's primarily for English. And then we started engaging with InfoBeep. They have a program called Startup Tribe. And the good thing, the thing you realize is that if you want to work with platforms such as WhatsApp, then you have to get the API from Facebook or particularly, and then you have to work with a Facebook partner. And then that's when now some of the challenges started coming in from our idea to actually implementing it. So one of the things we realized is that the challenge for working with small businesses, especially if they're going to be using the WhatsApp API, is that every business for their number would have to pay up to 1,000 euros on for the beginning. So that's about 100,000 or 120,000 Kenyan shillings just to get a number that's connected to the WhatsApp API, and they have to go through a long authentication process. So now that became our number one challenge. How do you get that API for every business and for yourselves as well, the WhatsApp API, so that you can build your conversational AI and be able to now collect the data from your business about their product, about their stock, and be able to set up the conversation for them, conversational AI for them. The good thing with NVIDIA Riva is, it's very natural in the conversation that it can have with people. Their main challenges are understanding local language. And then your own challenges is like getting the conversation flows from customers so that you can be able to train it on their particular piece of data. Other challenges, as I mentioned, is getting that API from Meta. The other major challenge is, I believe right now, probably the best Swahili corpus is with Finland. I think the university, the National University there. Interestingly, I think second to that is there's the work that the Lacuna program is doing, particularly, and as well as Mozilla, trying to build like really good Swahili corpus. But then again, language is changing almost every day. So having something that understands, the colloquial language that people use, especially if you're working with entrepreneurs who are selling online, it's the demographic of people who are there is usually younger people, and the way they have those conversations is quite different. Cost definitely became an issue, because now we started realizing that the segment that we had focused on, it would be harder for them to afford the 120,000 shillings at the onset just to get their member, and then the continuous costs of each message on WhatsApp, which is usually around 5 shillings for every message. And so a lot of the businesses ended up being that they were okay with handling it themselves, because it's the same way they would hire one person and pay that person about 5,000 shillings a month just to manage the WhatsApp business line. So then that became quite a challenge there. And then also the cost of now building your own corpus for local language and trying to train that. So I think generally in the challenges that we've seen is that the open domain conversations versus the task-oriented conversations. Task-oriented conversations are pretty, straightforward. You can get people to just pick out the different things that they are asking for, as opposed to open domain conversations. So open domain conversations, it reminds you of I think in the 70s, you had ELIZA, which was pretty much the first one of the first NLP chatbots, so pretty much AI that was put out into public for people's use, and usually longer session conversations. So an example here would be, on the right for task-oriented, conversations. There's a lot of customer service, and it's, I think, much easier to build for clients and to have use, as opposed to open domain conversations where the idea is to have a very natural seeming conversation going on with somebody. But I believe with task-oriented conversations, that's what most e-commerce would require. But then again, people want a more natural flow of conversation, as if they were engaging with a human being. So recommendations from our side is, there's a lot of resources out there for helping businesses or engineers in businesses to set up these conversations. There's RASA, which is actually a really good open source platform for creating conversational AI. It's extremely good to use. And the other tools that are there, such as Lina by Google, Blender by Facebook, GPT-3 by OpenAI. I think GPT-3 are finally allowed, like, just you don't have to be on a waiting list. Anybody can use the GPT-3. Again, the challenges will always be language. Local languages. Business, if you're thinking of deploying machine learning and AI applications in the real world, is really trying to understand, because you can spend so much time building technology, and this is one of the things that we actually learned, that you end up having a lot of technical debt if you build things and then you deploy them fast, because it's much better to understand your customer, understand your market really well before you actually start building. So that's usually that's one of the things we learned a lot, because if we had spent all the time just building based on our own assumptions, would have ended up building something that people didn't actually want to use. Then finally is like, don't be afraid to fail fast and pivot and try to work on something else. So for us, we in many ways we still see the opportunities within what conversational AI can do on the continent. There are a lot of other interesting spaces that it can go into. We've built a lot of really good connections with companies such as NVIDIA, Infobip, as well as other people in the community, such as Mozilla, and having conversations with them. And we see this being applied in other ways. And even though it didn't work out that well for our intended customers, we do still believe we can be able to somehow reduce the costs and find alternative channels to use it. So probably standalone chat interfaces, rather than having to go through using WhatsApp until it becomes affordable enough for smaller businesses to use, right? So that's generally what I had to present. I wasn't going to go that deep into the technical side of it. My CTO is the one who's way more conversant on that than I am. So I hope I've been able to share a bit of our journey and success or failures in that particular space. But I'm definitely open to questions.
Thank you so much, Madembe. This was a great presentation, and it's also nice to see the application side and the business side of things. A nice contrast to the more technical presentations we've seen today. And if the audience has any questions, please put them forth.
I have a question. Yeah, thanks, Madembe. A really interesting look into a lean approach, basically, to an AI startup, and then how that plays out in practice. So Yeah, at Ubuntu, we are no stranger to, let's say, more generally integration problems. So you might have an idea of getting some sort of data and then training some sort of algorithm on it to achieve something, but then yeah, things can go quite wrong. So here we can say, okay, sometimes the data source itself is not practically available. Like here, it's too costly. Sometimes there might be alternative routes available though. Like, okay, if you cannot get access to the WhatsApp API, could you somehow get access to that data anyway? If the user wants to give it to you. Like, for example, there's also the WhatsApp web interface, and there was, some time ago there was a court decision in the US about LinkedIn. They had filed a suit against somebody who was basically scraping LinkedIn data for data usage purposes, and LinkedIn was saying this is our data, you cannot scrape it, but the court says no, actually, if it's out there on the web interface and the user has access to it, then they can also scrape it and give it to whoever they want because it's their data. So I mean, is something possible like this, like via WhatsApp web? Have you looked into that, or any other avenues to alleviate?
So interestingly, so while we're talking to people in the community, the great thing is like there are a lot of helpful people in the community, even particularly to go around the challenge for the WhatsApp API. There's actually other ways that people have figured out to get a WhatsApp API by paying like a third party who has somehow gotten access and giving people in general. But the challenge with that is like, yes, we get that one and we test it out, and it gives you it charges you a certain amount. But as you were saying, when if at some point, because I believe even over the last couple of years, because a lot of people I've seen in places such as Japan, in India, who have actually come up with such solutions, and they've scaled interesting companies on just basic chat. But then I believe there was someone also who has been working on Twitter a couple of years ago, and just one day, Twitter decided to cut the API access to them because they were making a lot of money, and Twitter wasn't able to get a good percentage of the money from them. So I think there's a risk sometimes to using other platforms and also to using unofficial channels to build your solutions. So that's a bit of a challenge. So unless you're able to become part of the business suite, because I believe even in Africa, there's only 2 Facebook partners who can have access to WhatsApp. So yeah, so it's a continuous learning process, and now we're trying to see how this can be used in other things. So for example, such as media monitoring, especially now that Kenya is going towards an election, that could also be something that's very interesting, particularly for local languages. So this would be interesting for vernacular languages. The last couple of elections when we've had issues in the country, it's because of lack of access. And I think at least one particular language is very strong in terms of its corpus. I think that's Luya. There's a lot of work that has been done there. And I think from the Lacuna Fund, I think there's a lot of more funding being put for other things. And the interesting thing now, as we've been looking at this space, we've realized, so I think today, a lot of advertisers are preferring advertising on vernacular stations. So right now, there are no proper solutions for automating media monitoring for advertisers and for products to make sure that, hey, your advertisement was aired on time at the same time, because a lot of not media houses, but agencies required to report this data to their clients. And a lot of clients are always trying to make sure that, hey, we are paying these ad agencies to get our advertisements out, but right now it's a lot more difficult to monitor the vernacular stations, which most people prefer pushing their products through those these days. So it's been a lot of learning through this process. So yeah, even though it didn't work out, we're still in the space. And I see a question from Bebeto. So strike the balance on the issue of deep fake. Yeah, so that's generative adversarial networks. So the interesting thing about that is we have also been looking into creating our own synthetic data for whether not only for training in different cases. The good thing we see with synthetic data, which is actually a benefit of GAN to some extent, is that it reduces your privacy issues with people, right? If you create enough synthetic data, then you sort of get past the privacy issues with people. So if it's, for example, in fintech and you want to create your credit scoring models, you can use synthetic data to get away from the issue of people's M-Pesa messages being particularly personal, right? But you can create enough parameters that the model gives you something interesting. And we've seen this particularly happening a lot in Europe with banks creating a lot of synthetic data. There are startups who are mainly focused on synthetic data for companies. We do see the space we are in is actually becoming interestingly competitive in Kenya with even Auni. So you have players such as CM.com, Ajua, other players. I think Ajua acquired another smaller company called WireWire. And so what they were able to do, through just messaging, you integrate payments, a payments link, and the conversation. So social commerce can work really well. YC has been taking up since, I think, when chatbots was a big movement back in, I think, from around 2017, 2016, 2017. A lot of YC companies were funded. I think India, it really blew up, and that's so. If you had been in India before their last election, that's when chatbots really blew up because they were being used for the campaigns. But then since then, and the amount of power they had on elections, Facebook created a lot of restrictions on what people can keep on sending on WhatsApp, and how you can engage people who you probably don't have their number already. But yeah, so this are a couple of the things that we've learned also during this time.
Hey, if I may ask another question, pushing back a bit about your earlier answer about, okay, we need to be careful with what services you rely on, because, yeah, they could be shut off any time. But on the other hand, on the earlier slide, you said, okay, use pre-existing services, right? Don't build everything yourself. I mean, that's sort of a tech lead dilemma of the day, right? I mean, every day, basically, like, okay, build yourself versus buy. So, okay, so on one hand, yes, we definitely want to reuse other services. On the other hand, we don't want to be so dependent on them that we have to shut down the business when something happens to that particular service. What's your take? Like, how do you strike the balance? Where do you draw the line?
Yeah, it's an interesting balance because, for example, if we decide to go on our own, then we don't have the billion plus users that WhatsApp has, right? So that becomes a challenge. So what's already there sometimes gives you scale very fast, and you can be able to reach a lot of people if it's reaching businesses and people. So, and then, for example, if it's using NVIDIA Riviera, for example, which is, they've already trained, it's millions of hours of training, right? As compared to for us starting or trying to get access to GPUs and other ways of training. So there's a balance of trying to see, okay, if the number one thing we want to do is to get to market as fast as possible and deliver the solution, then usually the fastest way is to go with the players who are the ecosystems that have already been created and provide a solution within that ecosystem. So, an easy plugin that can be used on Shopify or on Facebook or on other platforms. And then just designing that small application and make sure you always follow all the regulations of that particular platform. But now when it comes to doing things such as creating your own corpus, right? If it doesn't exist, then you probably have to. Now, one of the biggest challenges we faced was trying to go to investors, such as VCs, and get them to believe that, hey, you know what, there's going to be a big opportunity for conversational AI in Africa in the next 2 to 10 years. Most of them would be, a lot of times, especially I believe in Africa, they are a lot more reserved when you're telling them about you're trying to raise money for a use case in AI, and it's you have to actually build the data sets yourselves. So they're always wondering, are you like playing? Are you gambling? Which is the right language to focus on? Which is so you have to really try to convince them, or to go to an investor who really understands technology and is really someone who understands sort of, the risks as well as the opportunities for the future. I'm seeing something really interesting. Okay. Thanks, Wame. Yeah. So even right now, we've been seeing a lot of other possible use cases. So for example, there's one interesting company called Viamo. So what they've been doing, they haven't been using a lot of intelligence in their systems, but what they've been doing is they've been doing interactive voice recognition, interactive voice response with farmers. Or in healthcare, like in COVID, this was a big thing. They've been doing this in quite a lot of markets, in Rwanda, in Ghana, in other spaces where, it's the same thing. Like, you press 1 for advice on what crop to grow, when best to do. And so we see a huge opportunity in conversational AI being applied there, where instead of it's just normal interactive prompts, it becomes an actual conversation in local languages, because we know, for example, most farmers on the African continent are 60+ years, literacy levels are low. So, there's a time we actually did a bit of research, and we realized what most farmers usually do, especially next generation farmers. This was a particular lady where she was now living in Gong, but she's from, I think, Vihiga. And so anytime there was, a pest problem in her farm in Gong, she would call her dad and ask, what do I do about this? And she did not have a smartphone. She just had a normal, 2G phone. And so we see the opportunity for conversational AI also in that particular space, still agriculture and in health, where instead of the normal, having to call an agent or, having to call that relative you trust, maybe they might not have the particular answer that you want, or as advanced an answer you want, you do that. So we started seeing a lot of other opportunities we could put this in, and finding people who are willing now to pay for this service, because that's the other thing. A lot of times you might have this really cool innovation using machine learning, deep learning, or other AI techniques, but who's going to pay for it and pay for the cost of you developing it? And that's why I think a lot of times the VCs and investors are a bit skeptical about putting more money into this space. I hope, Bastian, I didn't go too far from the answer.
No, thanks. Yeah, I mean, that's very interesting stuff for sure, and shows a bit about the challenges of applying AI that are not just purely technical, but also like setting ecosystem data pipelines around it, and data pipeline not only like, okay, you are ingesting some data from some source into your technical pipeline, but also how you get access to that data, which is an issue for many starting companies?
Yeah, I think technical wise, we've realized that there's a lot of support out there from, of course, from the bigger players who want you to belong to their ecosystems, whether it's Microsoft, whether it's Google, whether it's AWS, NVIDIA now, because NVIDIA is now really, really aggressively coming into the market with all different kinds of support, education-wise and other spaces. Now, the question is always like, if on the business side, are you able to come up with a good enough model, understand your customer, understand the product you're building? You'll get all the support you need, but now the commercialization part of it, that is, and I think it's unimaginable, and everybody's trying to figure that out. So it's always the problem you're solving, then AI techniques, machine learning, deep learning, how is, what is the, is this a problem that can be, resolved by basic data science? Is it a problem that only if you use machine learning or deep learning will you be able to come up with a good enough solution that people will be willing to pay for? Because customers are always, price sensitive. But if they see that it's definitely something that is going to save them a lot, and by them, paying for you using a more advanced technique, then that's when it makes sense. And I think for us, since we as a startup, you're always thinking about how you can scale as fast as possible, and you can make profit for your investors and benefit for your customers. We've always had to think about that component of it, and not just the technology side of it. But as I said, we've realized there's a lot of support on the technology side that's out there.
Thank you so much, Mutembe. Before we delay too much, we need to get into the last talk for the day.
Sure. Thank you, Rahul.
Absolutely.
Okay.
Okay, now we have Eugene Ochieng, who is a big data engineer and the CTO at Owaka Robotics, Kenya. And he constantly likes to indulge in forums and discussions that are a lot more focused on big data and artificial intelligence. He has a Bachelor of Science in Information System Security and a Master of Science in Electronics and Telecommunications Engineering. So it'll be nice to hear from someone who is fitting into a different piece of the data science world, particularly big data. Over to you, Eugene.
So thank you so much for that brief introduction. Pretty much speaks about me. So I'm just going to share my screen right away, so we can start on this.
All good, Eugene? I think Eugene might have dropped off. Let's wait for him to get back. Hi, Eugene, are you there? If you're speaking, you're on mute.
Sorry about that. Just confirm if you can see my screen.
Yes, we can see your screen now.
Great. So again, I'm just going to give you a brief description of me in 5 lines. So that is my name in case you missed it. Eugene Ochieng, CTO, Waka Robotics, and of course, the big data consultant at Trigger Foods. Those are my credentials in terms of books and stuff. So I'm really interested in talking. Actually, this time I'm talking last. I have never really talked last, and it feels to me like a guest of honor in a fundraiser. So Waka Robotics actually deals with big data in terms of helping retailers and e-commerce in specific to leverage the power of data in their strategies, including market intelligence and pricing strategies. So there's been a big need of helping retailers to know what the right price for a particular product is within this period of time or within this duration. So we saw a need of starting up this kind of venture. So at least we can be part of this journey with retailers. We can give them a clear pathway of how the pipeline of receiving information and tailoring this information to getting strategies in terms of market intelligence for my product as a retailer, and of course, pricing strategies as a retailer. What is going to help me to get my customers to like me more in terms of my pricing and my outreach to them. So I'm just going to enlarge my screen now and then plug out. Yes. Okay. So we are going to move right to my first part of this presentation. So application of big data in retail. So
Eugene, sorry to cut you off, but could you put it on the full screen mode or presentation mode?
Yeah. It is on presentation mode. Confirm.
Oh no, we're seeing the document recovery and the tiles.
Okay. Let me see.
Yeah, on the bottom right over there, if you can click the right next to the zoom function.
Sorry. I'm not sure why it's not responding.
Okay, if it doesn't work, then I think we can go ahead.
Yeah, let me just do it as it is. So, So I begin with an introduction of what I want to speak, of what I want to talk about. So we are particularly focused on knowing what retailers can use big data for. And big data, what we are concerned with as an institution is to get this data as raw as it is from the World Wide Web, from other sources that I will talk about in this presentation. So personalization is one thing that we are looking at. And then for the e-commerce optimization, brand evaluation, right to in-store shopping experience. And then we have dynamic pricing, which is something we we really are focused on in terms of deriving pricing strategies for retailers. And then finally, I'm going to tackle retail analytics readiness and assessment. And in that case, I'm going to pick on a case study, just a brief case study to talk of it generally. So retail industry has its own share of troubles that we need to fight with in the industry. So as in any other field, big data in retail presents both a challenge and an opportunity. And so I have been listening to the presenters that have come before me in these sessions, and I have gotten a lot of stuff about predictive and perspective analytics, and so applying predictive and perspective data and analytics in real time. So we have retailers being able to glean valuable insights from their multifarious data and with customers in an extremely competitive marketplace. So here we are going to look at distinct areas where retailers can apply big data analytics and increase customer engagement and perhaps improve bottom line. So this boils down to tracing the transformative opportunities ushered in big data. So in retail, we are going to look at a case study where something proposes a pragmatic path for merchants or vendors starting out with the retail analytics journey. So I'm going to start with this proverb. One CEO or at Macy's, she says that information is going to be our generation's next neutral resources, like steam was. Hopefully, in the 19th century, that is. So hopefully, what I pray that I'm not sure whether information is also going to get obsolete the same way steam technology got obsolete over time. But this is the driving force that we are looking at right now, and hopefully, we are going to be able to work with it for the longest time. Now, today, retailers generate vast amounts of data across the numerous touch points in their multi-channel operations. So, as opposed to limited contact points in the case of brick and mortar store operations, customers now interact with brands across multiple platforms, be it web, be it social, be it mobile. All this generates a wealth of assorted data that we as an institution are interested in. So this mind-boggling surge of data is only expected to grow in the coming years, as recent studies show. And
Eugene, sorry to cut you off again, but you're still on the first slide for us. We're not able to see you move ahead. So you're still on the About Me page.
Let me see.
Could you send the slides over to me and I can present them for you if you're having issues?
Yeah, sure. Can you be able to?
Yeah, it's moving now.
Oh, yeah. Yeah, I'm sorry about that. So this is the point. This is the point at which I was talking about retail. I mean, data as a powerhouse for retail. I mean, this is something that is happening right now, and I was just talking about how retailers can leverage the power of data. And I was talking about how, you see, studies are showing that the surge of data is only expected to grow in the coming years because data in the retail industry is not less. Every person, every individual, every industry right now is in the retail industry by default. So data is only growing. So I was talking about the different areas where we can get brands across multiple platforms, and I talked about web and social plus mobile, and generating a wealth of assorted data from those platforms. So the crazy surge of data is only expected to go higher in the coming years, and those are showed by the recent studies in the industry. So the formats in which these enormous data sets reside, perhaps in on emails, online reviews and ratings, perhaps on images, videos, and blog posts, and so on and so forth. And then not to fail to mention the Wi-Fi signals. Of course, that is one major place that information resides. So, looking at this image, you can be able to see that we have retail here, retail data, and we have the different areas where we can extract this data from. Mobile. Look at this point where we have mobile, and then we extend it right to payments and GPS. We have in-store, getting data from in-store, especially in-store shopping kind of setup. We are looking at the customer interaction with products and with the information that you provide within particular stores. We have CCTV cameras and the point of sales systems. These are just but a few points where we can be able to generate this data from. So for retailers, data can be an asset only if they're able to make sense of it. So retailers are tasked with sifting through the enormous pile of to collect what is valuable, while ensuring that nothing relevant is lost. That is where we come in. So more and more merchants are embracing big data technologies, because this is only needed to achieve the goal with increasing precision. In an industry that is shackled by slow economic growth and challenged by disruptive trends associated with digital consumers, retailers are trying to increase their share of that kind of environment. So the application of data analytics is in retail improves operation efficiency, customer service, or product marketing strategy, then you realize that this is not an entirely new environment in the world of data engineering, or perhaps to an extension, artificial intelligence, especially in the sense that we are trying to automate everything that we are doing in our environment of e-commerce, for instance. That is why I was so interested in what the previous speaker talked about concerning social commerce. So I'm going to jump right into personalization as one means in data analytics for retail, big data analytics for retail. And I'm going to be so brief in each of these points. And I'm going to start on personalization. So retail industry is moving from that blinding promotion towards targeted and personalized offers. That is for sure. And independent retailers foresee data personalization as a top driver of increased revenue in an immediate future. So roughly 22% retailers already make use of data for personalized marketing. And perhaps another 45% plan to use it in a short while. And customer data has never been scarce in the retail sector. So employing techniques such as behavioral targeting and psychographic segmentation, perhaps, or purchase pattern analysis, all this comes or trickles down from big data that is harvested from different regions, different environments, be it the World Wide Web or the hardware that we have, including the CCTV systems. So recommending engines that rely on machine learning techniques and collaborative filtering algorithms can be used to promote personalized content, especially on websites. So social conversations are a treasure because of information for retailers who care to listen and, of course, act upon it. Being aware that a customer is planning a seaside vacation, a shop owner could perhaps get in there and give an irresistible one-time deal on a beachwear. You see, planning on a vacation, an event that is readable from a customer database. So connecting online and offline data enforces, the personalized retail trend, which strengthens what we call customer loyalty. And of course, that is only geared to improve margins in the long run. For retailers, what they always care about most especially is the sales that you're getting. And personalization is directly proportional and linked to e-commerce optimization. E-commerce optimization only exists because we have an e-commerce system. So, looking at this table, this chart here, we have big data logistics information platform. Now, speaking of e-commerce, we are looking at different aspects of e-commerce, because e-commerce includes purchase of a product and delivery of a product. So it's a whole chain of a customer being able to call for a product or order for a product online, and then they are going to finally get this product delivered to them. And that is what entirely lies in the e-commerce in the e-commerce sector. So big data here is collected, and this big data is reliant on the commodity. So this information about the commodity and this information about the customer is all clustered in one environment. So with this kind of information, we are able to know what commodity sells faster, or perhaps what commodity sells in what environment, or maybe what commodity or in what quantities is this particular commodity preferred by this kind of customers. And then the customers, how do they perceive this commodity? How long does it take for this customer to look for this kind of commodity again? So it's about the customer and the commodity, how this commodity reaches the customer through customized delivery, perhaps, and of course the delivery company. A lot of companies have in-house delivery, and that is something that we can always look at in a different forum. So we also have storage. So you see, when you have products that you're selling to your vendors, then you're looking at taking care of your inventory, in the sense that when you need to stock commodity X, and how fast this customer XYZ are able to use up this product from your storage. So we are helping clients to get information about what they need to do in terms of stocking their products, and how long it takes for their products to stay in the warehouse, and then how fast this consumer is taking it, and also the feedback that the customer is giving back. So e-commerce is still a low source of revenue for independent retailers, that is for sure. So however, e-commerce is emerging as the business function with the highest potential opportunity, especially for analytics impact. So with big data analytics, retailers can improve the performance of their online stores to generate greater revenue out of them. Digging into websites, for instance, digging into website analytics, heat map studies, clickstream data, and such. Retailers can optimize product landing pages to ensure a greater engagement and conversion rates. And individualized product recommendations and offers, especially based on historic and footprints of customers. These can always be sure to increase the chances of click-throughs and of course sales. So items can be promoted, scrutinizing data points such as product browsing activity, by region. And for instance, demand for different garment sizes can vary drastically across geographical areas. Talking of Kenya, we have different areas, temperate regions, and we have equatorial regions, all with different environmental conditions, trickling down, especially about weather conditions. So you likely to get different garment sizes and perhaps the different garment materials, perhaps cotton, nylon, and so on and so forth in different regions. So you're able to plan with that kind of information, depending on what your customer base is and what your customer location is. So there's one important part that also connects to this this directive, and we are looking at brand evaluation as a part of getting your business objective right. So non-transactional data, we actually look at a data type, and in this case for brand evaluation we focus on non-transactional data and transactional data. And for transactional data it's purely on performance and the data exploration of the same. But for non-transactional data, we focus on the social analytics and decision science. So decision science is, we take it as the information that we are able, the end game that we're able to achieve based on the social impact in the industry. So what happens in the social life, especially what we're looking at is the feedback on the social sites. What happens there is what we leverage on to get our information on this particular box of decision science. So social media channels and online networking platforms contribute immensely to the big data onslaught. Retailers are seeing, of course, boundless possibilities from information mined out of these platforms. This ranging from market trend, forecasts, and holiday shopping patterns to product or service feedback, and perhaps brand evaluation as well. So customers voice their frustration and delight strongly, perhaps through social media channels. That is the most part that we know. Social media channels is where most customers now always go to place their frustrations, and that is where, as retailers, we always go to learn what to do best and why not to do it the same way we did it. Those are the kind of reasons that you always look for from the social sites. So we, following conversations on strong detractors, retailers can try to understand root cases for dissatisfaction and perhaps address those issues directly to improve brand perception. So social sentiment analyzers also, because these capture social chatter to categorize them as positive, negative, or neutral. All depends with what your brand is all about. So retailers can also monitor those sentiments in real time and analyze the sentiment trend over a period of time to measure the effectiveness of marketing campaigns and perhaps limited time offers that a particular retailer has. So we are really keen in looking at the in-store shopping experience because we have major storekeepers that, despite the challenges that we have been going through as a globe, of course, the COVID-19 pandemic that hit recently, there are big brands that could not just stand closing down their operations because we have a pandemic, so to say. But then they still were there and had to take precautions and of course follow guidelines that were available. So shutting down was never an option, and that means that however big the world grows, however big AI takes shape and people want to move from going to stores and all that, we could really not have everybody move from in-store shopping, to go out there and start doing e-commerce and all this stuff. So the main goal for analytics and employee interactions, because these in-house, you have to have staff that are working within, and you need big data to also control all this. So your goal should either be one, in-store shopping metrics that mirror online capabilities, and number two could be who, what, when, and where, how of customers. And the results finally of these goals perhaps could be the market segmentation. You as a retailer be able to segment your market from all these information that you have here. And of course, geared towards the goal of a business, a retail business. We also have predictive shopping behavior as a result at the end of the day, and of course, personalized marketing. So I'm going to talk about this in-store shopping experience briefly. And I'm going to mention that shoppers visit physical stores, that is for sure, to satisfy their sense, as well as to interact and socialize. And that is the major reason why at this day and age, we still go to these in-store shopping procedures. So retailers have to effectively combine customer data from online, social, and perhaps mobile channels with an in-store analytics data. And that is mainly to provide seamless shopping experience within the store. So from an interactive storefront and recommendations printed on till receipts, retailers both big and small, are really finding newer ways of engaging with customers and at physical stores. So video analytics help to identify hotspots with retail outlets, from data recorded on video cameras and CCTVs. That is where hardware gets in, because we always have a question of how we are going to leverage the power of hardware and big data. And that is where that is the major point where, as an institution, we use hardware to retrieve information or to harvest this data, to mine this data, to be able to work with these big in-house store retailers. So it's always about these videos, video cameras and CCTVs. And about social commerce also, we're looking at getting this information from what do we call them? Bloggers. And also, I'm losing the word, but I bet it will come in due time. So we are also looking at shelf layouts and end caps as a way that can be used to adjust and leverage these favored areas just from the information that we collect from this kind of hardware, that is the video cameras and CCTVs and so on and so forth. So dynamic pricing is a major challenge. We have retailers that we have been talking to for the longest time. A retailer that has 100 competitors online, but what they do is they have a major challenge, because today they are going to price their product at X dollars or X Kenya shillings, and they are going to have that price there for a whole of a month, and after a month, then they come to realize that other competitors that are playing in the same environment have been dynamically changing their prices at least once or twice a day. And in this case, these competitors are able to maximize on margins because they attract more customers at a time that a particular retailer has a constant price and a competitor has changed a price from X to Y. And this X to Y perhaps is a lower price price bracket. They're probably going to attract more customers in this sense. And then you as a retailer who do not leverage on the power of big data, then you're going to be in for a rude shock because you may wonder where your customers are going to. It's about customer loyalty. So customers always like it when they are loyal to you and you're loyal to them. And the loyalty for a customer is not always the quality for the first time. The first thing that they'll always look at is the price and the and how flexible this price is in terms of their pocket power and all that. So we always have this data that we mine from the World Wide Web. We have different players with different competitors. So what we do is we always get this data from the World Wide Web, and then we compare it with what our client has. And you know that 1, 2, 3, 4 of your competitors are selling this product at this price. But then you have this product at this price. let us run ETLs in this regard and get you the most appropriate price that you can use to outdo these competitors in this environment. So online sellers, of all sizes are catching up on data-driven repricing that has disrupted the retail industry. And price optimization software allows online merchants to hike or lower price depending on demand and sale of products at a particular time or a particular duration. So manually changing prices on every SKU. SKU is stock keeping unit, that is. So manually changing prices on these SKUs will not cut it in today's retail industry. An instance could be a retailer who has 1,000 products with 10,000 SKUs, for instance. So doing it manually is actually a liability to an industry, and it's going to cause a lot of brush of shoulders. Number one, there's that reduction of margins. You're going to need more manpower to do this manually, and then the accuracy is not also guaranteed in the long run. So we have pricing softwares that a lot of people use. So the pricing softwares can also have a minimum and a maximum price limits. And these price limits are set to ensure that prices displayed to shoppers and are always in the best interest of the retailer. So these kind of softwares we come up with and we tailor them for clients. And, these can only be done through getting this sample data from the sites, live streaming of data, pricing data from the different competitor platforms. And then we use this, run ETLs, and then we are able to get what prices that is within the minimum and the maximum. And you're able to know what prices are valuable for our client retailer to be able to work with, to ensure that they are not running at losses and they are not making too much that is going to ring bells and chase away their customers. So, using price optimization engines also, and retailers find it easy to clear old stock or protect limited stock to capitalize on surging consumer demand, of course, during peak season. Real-time monitoring capability of pricing analytics software. So this real-time monitoring allows online stores and also in-house stores to implement time-based pricing that is constantly, readjusted according to the time of the day and the stock levels. So tapping into customer shopping history and retailers, they can be able to offer flexible prices such as bigger discounts and perhaps bigger discounts, especially for repeat or regular customers in this case. So retail analytics readiness, and I'm going to give a quick description of a case study in retail analytics solution, especially for personalized service. And so what happens is insights from retail analytics can tremendously alter the way consumers and brands interact with each other. It can only be positive when you leverage the right big data, when you leverage on the power of the right big data. So you could, for you to positively impact brand affinity and of course profit margins, you have to do this right. So from dynamic price optimization to store design, and that is for in-house, and service personalization, application of big data analytics can for all the facets of retail industry, be it merchandising, operations, or perhaps marketing. You can name it. So, and this is a case study that we were looking at for this particular client called Clean Shelf. So CleanShelf actually wanted to recreate the convenience and efficiency of online shopping for their physical stores. And a brief introduction of CleanShelf is that they're an in-house store. They do not have online services like an e-commerce at the moment, something that is still in pilot, and hopefully it's going to work out right. So they want to make sure that they personalize customer shopping experience, and at the same time they need to ensure that they're providing retailers with precise data to inform business decisions. So the analytics solution that is in mind and had been implemented in some prior set of operations in this particular setup is one that integrates data from various online and offline channels to create personalized in-store experience for digitally savvy customers. So the shopper app that is in pilot to say actually utilizes micro-location beacon technology. So that is meant to help retailers promote products and offers based on customers' proximity to certain products or departments. And another thing is that administration and marketing consoles also help to analyze in-store marketing campaigns, positioning of end caps, store design, and perhaps sales information through data collected from locations throughout the store. So social media integration contributes really deeper insights into customer preferences. Because in a case where you do not have a way of getting feedback from your customers that is tailored to your retail business, then many businesses actually depend on social media, the power of social media to accept or to access this data in terms of what consumers think and how consumers interact with their products. So there's always got to be a clear-cut strategy and planning. And without which, the data analytics journey can turn into a nightmare for retailers. So we always advise that retailers that think, they are ready to dive into retail analytics and, in other words, big data analytics for retail. Then they need to check exploratory analysis of their business's data. Because they have the data already, and that should provide them an assessment report. And of course, the readiness assessment will deliver the recommendations and a retail analytics roadmap to help them get ahead with data-driven insights. I've really been trying to rush so fast because I realized we are behind schedule, and that is why I've been speaking like I'm losing it. So I'll pause there right now, and I'll actually be looking forward to listen to or get questions from anyone who has. Thank you.
Thank you so much for that, Eugene. Anybody have any questions? You can raise your hands or put them on chat. Go ahead, Bastian.
Yeah, thanks for that. Yeah, earlier you showed the pipeline and basically measure the customer, analyze, etc., and then.
Sorry, Bastian, I'm not sure I can hear you clearly.
Yeah, I can't hear you either.
Okay. Is this better?
Yes.
Yeah, sure.
Yes, okay. Yeah, I was referring to your earlier slide where you showed information flow basically from the customer to a central component, and then from there, yeah, information goes to, for example, logistic providers, storage, etc., to make better decisions. In the use cases such as Trigger, is there any privacy concerns and mitigation in place? Could, for example, every logistics provider in that setting infer which individuals they are serving, or is there any privacy preservation in place, basically?
Bastian, I'm not sure I got your question right. You're actually breaking. I'm straining so much to hear what you're saying.
Okay, sorry. I will write up my question, but it will take a minute.
Yeah, sure. Thanks. Okay. Okay, so you posed a question on the user data analytics component. So number one, we have challenges, of course. We are looking at the capability of ourselves being able to leverage on this kind of big data. And you also gave an example at Trigger, and I'm going to speak from a perspective of that. So getting in this information, we always have disclaimers, of course, because we do not get information that is not at our disposal. And by our disposal, what I mean is that we have a huge database, and this database is about publicly available data. So when we get this data from the public domain, then we believe that it is something that we can be able to leverage on, especially for the purposes of training and making decisions in terms of what we do. Now, this is internal process. There's always the question of security, the security reasons that may come in. But then we always try as much, and we talk to our users that because our customers are our users. And I'm talking from a perspective of a retailer now, and I told you this perspective is going to actually focus on Trigger as an institution. So there's always the question of security. The first thing that you have to do is that when you register to a platform as a customer, you have to always read the terms and conditions. We have outlined all these details that apply to what we pick your data for and what we do with your data and how long we are going to store this data about you and your and what you do on our platforms. We have that specified duration of time that you say this is how long we are going to have your data with us, and it is always at your own conviction as a customer to decide that this is not what you want and that you should not use your data and so on and so forth. So what we do is actually always in the description of all users generally, our customers, they always decide whether they want us to use the information for analytics and all this. So logistics, and then we always advise that logistics are always good to be in-house. We have not really worked with people or retailers who have outsourcing logistics services. So this means that the data that is collected is entirely used in the internal systems, in the internal operations purposes. So when it comes to security, then we always also have to ensure that we give these customers, the retail customers, all reasons to believe that, you know, this is the data we have and we are going to secure this data in this way and this way. So the first initiative that we take is always to communicate beforehand that, hey, you're using this system and this is what you are going to be able to do in terms of capturing your information. And this is the kind of products that you are going to tailor for you. And this is why we need your information. So in case you do not agree to this, then we are not the best people to do. So we always make sure that not only to this one client trigger, we always ensure that we talk to all our clients and our prospectives that before we start to provide you with any information or any data, big data solution, you always have to be ready to communicate this to your customers. They have to know the kind of data that you are going to be serving you with and why we need this data and how it is going to be helpful to them. And at the end of the day, we have two people that are happy, both the retailer and the vendor. So I believe that should answer the question. I tried answering it in a way that suggests I'm running away from it, but then I believe I really captured what I needed to capture.
Thank you, Eugene. Any other questions?
No questions.
Okay, great. I think then we can conclude a great set of talks. I really want to thank everyone for participating in this event, but it's not all over yet. So if you guys can get into GatherTown now, we can continue the networking sessions and also head into the talent show where we have people presenting their personal projects. And if you have any questions, feel free to stay here and ask me or put it on chat or Discord.
Yes, thank you all also from me. I think we had really interesting talks today. And yeah, there are still some people presenting their own projects on GatherTown. So GatherTown again is the link is in the boarding kit, but I'm also putting it in the chat right now here. Yeah, for those who have not been on there yet, it's a sort of virtual conference space. You can walk around there, find each other, and basically when you're near to somebody, you can talk and they will hear you, as long as you're not muted. So it's a bit like, yeah, you need to be close to each other to listen to each other. Then there are some rooms which are available for discussion, which yeah, allow basically everybody in the room to hear. Was I understandable, Rahul?
Yeah, we can hear you now.
Oh, awesome, thanks. Yeah, then see you in GatherTown.
I'm going to wait 3 minutes and then shut down this Zoom call. So if you guys have any questions or anything, now's the time.
Isaac here.
Bastian, you're unmuted on Zoom.
All right, thanks.
You guys can see the chat for the breakdown of the different rooms and the talent shows that will be there. So there's AI in healthcare, AI in construction, AI in parental supervision, AI in networks, and AI in career transitions. Okay, hope you all got that. We'll be shutting this Zoom link down. See you all on GatherTown.